Good morning. Hi. So we should start. Sorry. So welcome to Trento and to the second Italian Conference on Computational Linguistics. My name is Sara Tonelli, and on behalf of the other conference chairs, Cristina Bosco and Fabio Massimo Zanzotto, I'd like to thank you for being here, for submitting your papers, and we were able, thanks to your contribution, to set up a really interesting and rich program. The first edition of this conference was last year. It was organized in Pisa. And this time we are in Trento at Fondazione Bruno Kessler, which is also my institution. As some of you may know, there is a long tradition here of research in artificial intelligence, natural language processing, and computational linguistics. We have here the director of the ICT Center of FBK, and I give him the floor to say.
So thank you, Sara. Thank you to all of you for coming, and welcome to Trento. I'm very impressed to see so many people for this Italian conference from all over the world, but I know that, yes, not only from Italy, also from all over the world. I'm very happy to welcome you because, this topic is a topic for us of great interest. We have a long tradition of work, of research in this area, starting from the 80s. And as Sara has mentioned, in AI, but specifically also in computational linguistics, natural language understanding. I believe that we have something like a group of more than 40 people, 40 researchers and PhD students working on this topic, doing research. Sara is leading our group that is called Digital Humanities, and there is a lot of natural language understanding, a lot of computational linguistics to do. Bernardo, that is here close to me, is leading this research line that is called cognitive computing, where natural language understanding and computational linguistics is an important part. Also gathering competence in other areas like vision, like speech, like semantics, knowledge. I believe that this is very important also, that this kind of research is connected to different competences and joining different competences on some scientific common objective, I believe is very important, is the future for many areas in research. So thank you very much for coming. A real pleasure for welcome you to Trento. As you see, also the people that come from the south, also here in the north of Italy, we have some sun. It's not raining. Maybe there is not enough snow if some of you were thinking to go to skiing, but we have so very nice mountains. So for these 2 days, also enjoying the conference, but also enjoying Trento, enjoying the city, enjoying your friends here. So have a really nice conference, and I wish you very great work and collaborations, a very interesting conference. Thank you very much.
Thank you. So one novelty of this year, probably is that we have now an association, Italian Association for Computational Linguistics, which was founded a few months ago, and that this year and in the next years will manage this conference. So Bernardo Magnini is also the president of the association, and he's going to say something about this new activity.
Okay, so good morning, everybody. It's my first time that I read something in a speech, so I have prepared my speech. So I'm very pleased to welcome all of you to this conference. This is the second Italian Conference of Computational Linguistics. As you probably know, starting from this edition of the conference, CLiC-it, this is the name of the conference, is managed by the Italian Association of Computational Linguistics. In short, and let me use the Italian short name, AILC. This association, AILC, was formally established in September, so it's very new. The goal of the association is promoting and diffusing research practices, scientific collaborations, the development of language resources and tools, as well as technological competencies and the transfer of knowledge toward the market. All of this in the field of computational linguistics. This conference, the annual Italian Conference of Computational Linguistics, together with Evalita, probably some of you know about this initiative. This is the evaluation campaign based on shared tasks for the Italian language. And together with the newborn Italian Journal of Computational Linguistics are the main instruments of the association to accomplish its mission. You will have the opportunity to know more about the CLiC association during these 2 days of conference, and very important, you have the opportunity to vote for the new board of the association during the assembly of the association member today in the afternoon. The association and the board that will be elected today, both of them, they need the support and the active participation by all its members. On behalf of the association, and in particular on behalf of the persons who started the association during the last year, so the current and temporary board of the association, I would like to thank many persons for the organization of this conference. First of all, the 3 conference chairs, so Cristina Bosco, Sara Tonelli, Fabio Massimo Zanzotto, all the area chairs, they all set up a wonderful program for the conference. I would like to thank the local organizers at FBK, particularly the people of the Digital Humanities Group, and the person at FBK of the event office. I would like to thank the 2 invited speakers, Paola Merlo and Enrique Alfonseca. I would like to thank the invited panelists. You know that we have 2 panels at the conference. In the first one today, we have representatives of the Italian associations in the area of language. In the second panel tomorrow, we have representative of Italian industries operating in the field of computational linguistics. I want to thank all of them. I would like to thank the sponsors of the conference for the generous contribution to the organization of this event. And finally, I would like to thank all the authors of the paper and all the participants in the conference. I wish you a very fruitful, interesting conference and a pleasant stay in Trento. Thank you very much.
So to conclude this introduction, I would like to give you just some numbers about the conference. So as Bernardo mentioned, we are here, and thanks also to the local organization of PK, and we are happy because we had really good participation and involvement of researchers. So we published in the proceedings 52 papers divided into 10 tracks. Overall, we have 128 authors coming not only from Italy, but also from abroad. So 39 institutions overall are involved. And I think this is nice to see these numbers, because this conference is also an occasion to say, okay, what is our community, who are we, and which direction do we want to take? So you can see in Italy, we cover basically all Italy from Catania to Bolzano. Of course, big centers in Pisa and in Trento are very much involved in the conference. We are, as we said in the call for papers, CLiC should be an inclusive conference. So inclusive to us means also to look at the balance of the participants. And we think that for being a computer science related conference, it's pretty good gender balance, much better than other conferences in our area. We also looked at the age of our participants. In this case, we got these numbers from the registered, not from the authors of the paper, but from the registered to the conference. And you see that there are so-called regular is researchers older than 35. I didn't want to call them senior. So the regular and the students are very well balanced. So we can see also in the audience that we have also the researchers of the future, so the next generation of researchers in computational linguistics. As for the tracks, we have some keywords which are very, very important, very frequent. We have corpora, a lot of presentation on resources, but also on algorithms, semantics, parsing, sentiment analysis. So the main keywords that you find also in other international conferences are the same that we find in CLiC. As Bernardo mentioned, we have important companies supporting us. There will be a panel tomorrow. Of course, we are very thankful to their support, and one we reveal will also sponsor one of the best papers. And also, we got the endorsement of other associations related to Italian associations related somehow to research in language and linguistics. And for this, there will be a panel today. So last slide. It was already introduced that we are all under the umbrella of ILC, and we will also elect tomorrow today, sorry, the new board. So thanks, that's all. Enjoy CLiC, and now I'm giving the floor to Cristina for the introduction of the invited talk.
Okay, also one small technical note about the proceedings. You can find the proceedings in the website of the conference. Oops. And this is the website of the editor, which can be accessed by the conference website. But you must select the proceedings here, and then you must select this link, and going down you must buy the proceedings, but for free, okay? You must register yourself with some data. When you select this link, you must go to the carrello, okay? You must put your data, okay? And the download is for free, and you will receive in a few minutes the proceedings in your email, by email, okay? Thank you. Okay, now I must present the first invited speaker, and I'm very glad to introduce Paola Merlo, which that is our first invited speaker. Paola is known in the community, but I will spend a few words just to introduce this important person within our area. Paola is a professor at the University of Geneva in the Department of Linguistics, and she's the head of the interdisciplinary research group Computational Learning and Computational Linguistics. She is also editor-in-chief of the Journal of the Association for Computational Linguistics and member of the executive committee of the ACL. The research interest of Paola Merlo span several topics within the area of computational linguistics. and are featured by multilingual perspective and a corpus-based approach. And among her the works, the more known are maybe the contributes about argument structure and verbal argument structure, and also the contributes on language universals, and the talk that Paola will present today is about language universals. Okay, the title is The Quest for Language Universals, Multilingual Computational Results and Methods. Thank you.
I have a version with notes on this side. Thanks. I think I need to change glasses here. Well, thank you, Christina, for the introduction, and thank you very, very much for the invitation. This is fine. Thank you very much for the invitation, and I'm really glad to see so many people. I'm really glad to hear about this initiative and that you have now an Association of Italian Computational Linguistics. I am fighting a similar battle for Italians abroad, and you know, we have the same difficulties in other linguistics departments, and I know exactly what you had to do this. So I'll give you my perspective on what I think is an interesting area, and I'll concentrate. I saw that the other invited speaker is from Google, so clearly my role here is to give a perspective from the computational linguistics side more than from the natural language processing side. So during the Second World War, the Americans realized that their encryption code had been cracked, that the Japanese were deciphering their messages. So what they did, they enlisted, to solve this problem, is that they enlisted 11 Navajo speakers that from then on to the end of the war acted as the so-called cold talkers. They encrypted the messages that were never decrypted. The Japanese never realized that the messages were being transmitted in Navajo. This is a famous episode of a Navajo cold talkers. This technique has been used in other cases for war code messaging. And it's a perfect example of two apparently conflicting properties of natural language. Natural language is very diverse, so diverse that speakers of English, Japanese, and Navajo do not recognize differences in the languages. But clearly they are very similar at some other level, so that you can do fast, accurate translation under the constraints that one can imagine are imposed on transmission in wartime. So clearly these are properties, and these are properties that we have used in computational linguistics and in natural language processing for the applications and the theories we have developed. We can improve performance of monolingual applications by adding or creating new multilingual information. We can leverage the similarity across languages to have more data. This has been used in transfer approaches, mostly in transfer approaches. And we can also leverage the differences across languages, because information that is covert in a language can be overt in a different language and be used basically as an annotation. Languages can be used as annotations of each other. And obviously, when we develop truly multilingual methods, we are aiming for a level of representation that is more abstract and that is common to all languages. So we can study the similarities and differences across languages to develop truly multilingual natural language processing tools. So in computational linguistics, or other natural language processing, these multilinguality and approaches to multilinguality has been driven by technological aims and technological goals. But we can also study, to achieve truly multilingual methods, you need to understand something about the underlying cross-linguistic regularities
that are underlying all languages. So this technological drive to multilingual tools can and has pushed us to study and discover and formally describe some very basic cross-linguistic regularity. And by very basic, I mean very abstract, very fundamental cross-linguistic regularities. So I have, as I said, I have been asked to give a talk on my view as a perspective from the editor of computational linguistics. Now, computational linguistics is not a future trend indicator, it's rather a sort of past trend indicator. But what we do see is that there are more and more submissions about stranger and more interesting languages. It's really spreading to well beyond the European and the most spoken languages. So it seems to me that one of the main goals of computational linguistics and natural language processing should be to address these important linguistic problems. In the computational study of intelligent behavior, the domain of language is really characterized by a long-standing, sophisticated domain theory. And so we should develop methods that find a way of combining sophisticated domain theory representations with large scale. We also have a lot of data, so with large scale statistical approaches. So the kind of work I'm going to illustrate today, and I'll just do a sort of smorgasbord of case studies of work that we're developing and studying in Geneva. I will report on work that is aiming to study the quantitative properties of abstract linguistic representations so that we can reach an understanding of why is it that statistical methods are so effective, because unquestionably they are. But so we should understand what are the statistical linguistic properties that underlie these methods. And so I will concentrate, because this is my current interest and it's typical linguistic interest, I will concentrate on what is cross-linguistically valid and approaches to cross-linguistically valid theories. And I've been interested recently in using data and studies from typology, so from that branch of linguistics where people really study large-scale samples of languages. And I will present some studies on language universals, in particular the Universal 20, the universal that governs the internal structure of a noun phrase. Another universal has been recently discussed with publications in the National Academy of Science, dependency length minimization. And then it will move more towards natural language processing problems, showing some work on cross-linguistically valid properties, how we can study them, how we can make the link between typology and corpus frequency in ways that could be useful for natural language processing. And I will conclude with a case study on learning the narration of events, where we really use linguistic properties to do basically annotation and reach results that are comparable to results that have been achieved by large-scale, massive methods. We do it with 2 features and 600 examples. So I'll start with Universal 20. Universal 20, for those that don't know, is one of it's a name that is one of Greenberg's universals, and it describes the distribution of elements inside the noun phrase. So in the formulation of Greenberg in 1963, Universal 20 says that when demonstrative, numeral, and descriptive adjectives are found in this order, they precede the noun. If they follow the noun, they are found either in exactly the same order or the following order. So basically what Greenberg is saying, you find demonstrative, numeral, descriptive, adjective, noun, or you find noun, demonstrative, numeral, descriptive, adjective, or the mirror image. You find noun, descriptive, adjective, numeral, demonstrative. This was based on a sample of roughly 40 languages. We have now much larger samples collected by Matthew Dreyer here in Italy, by one of the best known people that working on this thing is Guglielmo Cinque. He has a database of 1,500 languages. This this universal has been confirmed, but it is too strong. We actually find distributions, I have discretized it to make it less rapidly obsolescent as we find new languages, but the distribution is like this. So Greenberg's universal is confirmed. The first order I've listed there is one of the 3 orders he listed, and then the first of the last group is one of the orders he listed, and the last one is the 3rd order he listed. So you can see this order obviously are observed. 2 of them are very frequent. They are the most frequent orders. The ones that have a noun at the edge are the 2 most frequent orders. But the 3rd one he listed is not one of the very frequent orders. And there are many others that are also possible and that have been attested across languages in the world. When I say frequent here, I mean how many languages in the world have this order for the noun phrase. So some orders are just not possible. And some orders are rare and others are frequent, and 2 are very frequent. We find it really in the vast majority of languages in the world. So one of the questions we can ask if we want to study properties statistically or, quantitative properties is, where do these frequencies come from? What is a model that can study these frequencies? There have been models that have been proposed in the usual approaches that are based on notions of markedness. And the models tend to explain why languages are possible and impossible. More rarely, they try to explain the actual frequency distribution of languages, but there are several proposals. This is actually a topic that is now being very largely debated. I've just learned about one new model just the day before yesterday, so I can't talk, I don't have anything to say about it, but there's very active research. 3 of the best known models are Cinque's, Saisu's, and Dreyer's model. So Cinque has a model that is a generative model that is based on a fixed word order of the elements, and then movement operations that explain how we create, how we produce the other orders, and the markedness of these operations predicts the frequencies of the orders. Saisu's explanation is a factorial explanation where different factors combine with different weights. And in particular, there's a preference for having the heads of a noun at the edge of a phrase. There's a preference for the demonstrative to be at the edge of a phrase and to keep the adjective near the noun because it's the closest modifier. With a linear regressor, he can show with different weights that he can capture the data reasonably well. Dreyer's has a more traditional typological approach where he proposes factors that are based on harmony and symmetry. As you can notice, the 2 most frequent languages are languages that would be called harmonic. So the order of the dependent and head, to use the sort of dependency tree bank terminology that we often use these days, are all in the same direction. So computational models can be used and we actually need only very simple computational models to ask questions that are the typical linguistic questions. What is the generalization ability of these proposals? Are they subject to frequency effects? Are the markedness of the operations really as proposed by the linguist? And are the primitive operations proposed really independent, as it is claimed, independently justified, or are they in some way specific to this problem? And so the computational approach would be to translate these proposals into a computational model. The proposals are simple with a few factors, and so we can develop very simple computational models. What is difficult is really the translation of the model into the computational methods we use in computational linguistics. If we use a classification-based approach to testing generalization, we can interpret the different proposals that have been proposed and transform them in vector-based representations and then run a statistical model. So for example, to take some of these proposals are already expressed as features or constraints, so their translation to a computational model is not that complicated. The proposals that come from the generative tradition are usually a little more difficult because they are derivational proposals. They have this notion of movement that does a lot of the work, and so it's more difficult to translate them into the kind of models we're used to using. But so, for example, for Cinque's model, I've tried different translations, but we can translate this model into movement operations, existence of non-existence of movement operations, and existence or not existence of merge operations, so creation of structure, so that we can formalize the model in with 5 or 6, 7, depending on the translation we use. But here I will show you results for 5 different features. So 2 features that simply say, is there complete movement, or does the noun move all the way to the other end of a phrase or not, for example? Is there partial movement? Does the noun move only to an intermediate position in the phrase, to a middle position in the phrase? And what kind of combinations of adjective, noun, numeral, adjective, determinant, numeral is there, in what order? Or we can construct the phrase. If we do this kind of translation, then we have a vector-based representation for this theory for each example, and we can apply any kind of classification method we are used to using. And I have decided, I will show you results based on naive-based and relaxed version of naive-based, where the independence assumption of naive-based is relaxed, and 2 of the attributes, so there is 1 dependence between attributes, not all the attributes are independent. It's a weighted average 1 dependent estimation based model. So they're both probabilistic. This is a controlled comparison, it's a minimal pair. They're both probabilistic. One has fully independent attributes and the other has partially independent attributes. We can do type-based classification or token-based classification, the usual 10-fold cross-validation. We have several predictive regimes, so kind of thing that linguists are interested in. What are the possible languages and the impossible languages, or more fine-grained predictions? What are the frequent or infrequent, rare languages? You can discretize at different levels. I've tried 3 different levels. There's no theory of how many different levels there are, so I've tried several. And these are the results. So for Cinque's theory, so the italics number, this is the percent of language or language type that are classified in the right frequency class. So the prediction of the distribution of frequencies. And the the numbers in italics are those that are below the baseline. The baseline is obviously the most frequent class. And so these I don't know, we can concentrate on the possible, impossible, so the binary classification or the 4-way classification, very frequent, frequent, rare, impossible. And you can see there that these models are not as well fitting the data as the linguistic literature would let you to imagine, because these are presented in the literature as models that explain all the word orders. Clearly, we have applied here the typical technique we use in computational linguistics of keeping a held-out test set, and that gives us a different result. So in terms of test of generalization, using computational methods gives us a different point of view on the generalization ability of these models, and some fare better than others. Some are more complex than others, so of course give themselves a better chance of fitting the data. But for example, this tells us that a 3-factor model is not sufficient to really capture all the difference in complexity that leads to this difference in frequencies. From the point of view of frequency and markedness, there is a whole line of discussion in typology whether frequency is the same as markedness is the same as frequency. This classification shows that frequency and markedness are not quite the same. The markedness that these theories come up with, especially the proposal in Cinque, the markedness proposals he comes up with to explain the frequency distribution of these word orders is not what we see in the probability distribution of the computational model. And in particular, the movement that is usually in linguistics considered more marked, which is partial movement, is actually the most frequent. So we have to do some more thinking about this relationship between frequency and markedness. And also these models are sensitive to the frequency, have a hard time classifying rare events. So they're not quite good enough yet. In particular, unattested word orders are often classified as rare. This might mean two things: either that the models are not good enough, or that this distinction between rare and unattested really is not very informative. As we grow the sample of languages, we find word orders that were classified as unattested 50 years ago. So maybe we want to get rid of this distinction between possible and impossible and just talk about the frequency distributions. And then finally, there is always a lot of emphasis put on how independently justified the linguistic theories are and the properties of a linguistic model are. And so computational methods allow to test us empirically, basically, by comparing different models. Here, if we compare the two probabilistic models, one, the naive-based, the one that has the full independence assumptions, we compare it to this partially dependent classifier that for the rest has exactly the same properties. We see that Cinque's and Dreyer's models have better performance than the naive-based, where Siso's model has the same performance. This means that the primitive operations of Cinque's and Dreyer's model are not as independent as it is claimed. Clearly, there is dependency in the data that is giving them some of the results, while Siso's smaller model, in that respect, fares better. This is conceptually very important, because often these operations that are proposed in linguistics and that we use as properties of our computational models, even in corpus-based, evidence-based computational linguistics, are proposed because they are justified by other phenomena, by other portion of the data in linguistics, and so they are imported as independent properties. So this was just a first example to show that computational models provide a sound, precise, formal methodology that allows to test some very basic claims that we find in the linguistic literature, and that can yield different conclusions. It's also a method to set weights of this model once we have formalized them, so that we can address the notion of markedness, which is a very fundamental notion in cross-linguist comparisons, as well as testing claims of independence of the primitives of the theory. Another fundamental question in linguistics is how, so this was work on typological universals, so at the type level. But another fundamental question in linguistics is how universals emerge from natural language variation. So if you really look at the individual instances, there is variation, and how does that pan out? Is there just variation, or are there universals? This is not an idle question. The notion of universal, the existence of universal has been challenged recently in widely discussed papers. So this is actually not an idle question. One universal that has been proposed very recently is this general tendency of moving heavy phrases towards the end of a sentence. So if you have two sentences like, he put a box that he carried from downstairs on the table, you tend to prefer to say, he put on the table a box that he carried from downstairs. So you tend to move the long, heavy, so-called heavy phrases towards the end. This is a widespread phenomenon. Like here, I have some more example. If you have an alternation between prepositional phrases, you prefer the first example I've put there. You prefer the short first and the long last. Same for alternation between direct and indirect object. An example for French here, it's true across languages. Verb particle constructions, same thing. Clitics in Italian and French, same thing. It's a widespread phenomenon that has usually been characterized as heavy NP shift, heavy XP shift, right? In fact, what I'm going to present here is that there's a better quantitative tendency that explains the data better, which is to say, which has been called dependency length minimization. If two alternative orders are possible, the one which yields the smaller dependency length is preferred. There's a functional explanation for this. You minimize dependency. If it's a processing principle, you minimize dependencies basically to keep memory load reduced, or processing load to reduce processing load. It's also a more cross-linguistically valid principle, because the principle of end weight actually has to be reversed for head final languages. Head final languages like Japanese put heavy first and short closest to the head. So the linearity of a sentence does not map the shift of the heavy elements. When did I start? I didn't look, and I don't know how much time is left. I have another half hour. Okay, I just to know how much of each topic I need to go into. So this is, now we have, I thought this was particularly interesting because to do this kind of work, you need to have data and annotations that in computational linguistics we have, and that are not often used in theoretical linguistics. So now we have tree banks with dependency annotations. So a tree bank, a dependency annotated tree bank, allows us to formalize this notion of dependency in a more general sense, minimization, as the distance, as the sum of the distances of the arcs of the dependencies in the sentence. So the usual formalization of this concept is that the dependency length of a sentence is the sum of the length of all the dependencies, where the length of the dependencies can be calculated in different ways. One here that I propose is the difference in word indices, as I indicated here. So for this sentence, which is you'll see why it's Latin, it's the 14th chapter of the first book of the Bello Gallico. This sentence has dependency length 14. This principle of dependency length has been shown to be at work in many languages. There's a paper by Ted Gibson and his group that has appeared recently in the proceedings of the National Academy of Science that shows that this minimization of dependencies really holds for a lot of languages. Almost all the tree banks we can get hold of show this effect. So we studied whether dependencies in noun phrases, we stay in the topic of noun phrases, whether even inside short dependencies, short phrases, if this principle holds. This is an interesting question, because if the motivation is processing, is in memory load, it is reasonable to wonder whether we need to minimize very short distances, or we could just memorize them and keep them all as long as they need to be. So we studied the position of adjectives in Romance languages. So in French, you can say magnifique soirée à la conférence, une soirée magnifique à la conférence. Which one do you prefer, and what are the factors that influence the ordering of the elements based on their respective weight? And what they found, that for noun phrases, differently from the verb phrase domain, really it's a relative weight that matters. It depends on the weight of the things around it. So these are the structures of a noun phrase, adjective, and adjective. If we limit the study to one adjective, these are the structures we find. So we have an external dependent indicated here by X. We have a complement of a noun indicated here by Y, and then the different position of the adjective, the possible position, prenominal and postnominal. And the adjective itself could have pre-adjectival material, alpha, and post-adjectival material, beta. So for example, the dependency length of this structure is as indicated there. The dependency length 1 is alpha plus beta plus 1, that's the adjective, plus beta. So it's the length of D1 plus the length of D2, and then D3 basically is length 0, they're adjacent. And the DL2 has the dependency as indicated there. It has alpha plus beta plus 1. It's a dependency of D3 plus alpha, the dependency of D2. D1 basically is adjacent, has dependency 0. So those are the two alternatives in that structure between putting the adjective prenominal and postnominal. So the preference for putting the adjective prenominal or postnominal according to a dependency length minimization theory would depend. If you do the difference, it basically is beta minus alpha. So it depends on the relative length of beta and alpha, which one would be preferred. This is the other structure when you have the external dependent on the right with the same internal structure of a noun phrase. There it's much more obvious that DL1 is shorter than DL2. There's a much shorter distances. And so there we would have in this structure a prediction according to dependency length minimization that one prefers a prenominal. So the factors, so we studied this factor in 3 banks of Romance languages. So we have Italian, French, Spanish, Catalan, and Portuguese, because it's well known that Romance languages have this relative freedom, not complete, but wider freedom of positioning of the adjectives than, for example, English would have been completely uninteresting. There's no variation other than some predicative uses of adjectives. So in these 3 banks, we collect the counts on the presence. Just to give you here, these are the simple proportions of prenominal adjectives and the size of the data set that we're using. And we're fitting a mixed effect model where the fixed factors are this notion of left adjective phrase, so the presence of a left dependency of the adjective, so the length of the alpha, and the right AP, the presence of a right dependent of the adjective, the beta in my previous indication. The presence of an alpha favors the postnominal placement of the adjective, because that way the adjective can be adjacent to the noun, and the presence of a beta clearly favors the adjective's postnominal placement. It's a phenomenon you find, for example, in very proud man, where you can have a modification of the adjective on the left, and proud of his son man, where you tend to say a man proud of his son. You tend to move it to the right, not really because it's heavy, but because there's a complement to the adjective. Then the theory predicts that also the external dependence of the thing the noun phrase is attached to should make a difference. So, for example, there should be a difference between being attached to being a subject or being a direct object. And that would predict that the adjective is prenominal in subjects. And then the theory of dependency length minimization makes a prediction then when the noun has a right dependent, so when there is a Y, in my previous example, then the prenominal adjective would be preferred, because on the right you have the dependent and you tend to put the adjective prenominally. So it would explain why you have a preference for une île verte des Caraïbes rather than une île des Caraïbes verte. So the statistical model, the results, the model confirms in part the left AP, so the fact that if there is alpha, there is a preference for prenominal. In part, the right IP is confirmed, and also that the fact that a dependent of a noun phrase influences the position of the adjective is confirmed. The fact that the position of the head of a noun phrase makes a difference is not confirmed, and I actually think that's good news, because linguistically it doesn't make much sense that the position of the adjective inside a noun phrase should be influenced by the fact that the noun phrase is a subject of an object. I would have actually no explanation for that interaction. So we need to study. It very much depends. It is a prediction of dependency length minimization, so we need to explain why. One, why it's not confirmed. One possible explanation that has been put forth before is that in the definition of what a dependency is needs to be adapted to the cases. I should add, just for completeness, that this model has the actual adjectives and the languages as random effects, because clearly the preference for being prenominal and postnominal is lexically influenced and depends also on the language. Some languages are freer than others. But this dependency length minimization does provide a more precise explanation of word order preferences, so variation in word order across languages rather than a principle of end weight, and it does apply to short spans. So then now we need to understand whether we can keep a functional processing memory load explanation, or we need to develop a more sophisticated functional explanation for this effect. One thing that you might have noticed in comparing the previous case study, the first case study, the Universal 20 case study, and this case study, is that in the Universal 20 case study, the most frequent word orders were the ones that I said were harmonic. So were the ones where the head was on one edge of a noun phrase. So those cases clearly are the ones that have the longest dependency length, right? So they are the last example in my trees of dependency length. So clearly there are two principles here, a preference for harmony that we see in typological distributions, and a preference for minimizing dependencies that seem to be in conflict. And so it's interesting to see whether these two effects are in contrast, and if they are in contrast, how do languages develop? How do they evolve under the pressure of these two different constraints? And that's why we ended up with Latin and ancient Greek. That's why I had an example from Latin, because to study this question, we need to have languages that allow free word order, that allow all the options, for which we have well annotated corpora and for which we have large samples. And the languages that have these properties in our tree banks are Latin and ancient Greek. They're languages that have been studied in a text analysis tradition for centuries. So clearly the corpus work, the tradition of corpus work is very well done. It's very reliable. And the texts are large. These are languages that have a large documentation. Now we can study, so this, the other reason why, I forgot to say, that's a crucial thing. The other reason why we study these two languages is that we have text over a long span of time. So we can study texts that are BC and we can study texts that are AC. And so we can look at the change in time. And on top of that, we also have all the Romance languages. So, and we have modern Greek, for which we also have tree banks for which we can study the word orders. So we can then compare to the modern languages if needed. I'll give you just the examples from the ancient languages. And here we can calculate the diachronic trends of dependency length minimization. Here the green, so the blue curve would be an optimal dependency length. So if you generate artificially the dependency length for the linear order you keep, the linear order stays the same, the structure of a tree stays the same, but you generate the optimal order by just putting the dependence as close to the head as possible and starting from the shortest one, so that you guarantee that the tree has the shortest, the minimal dependencies. The red line is the actual observed dependencies, and the green line is the dependencies, the sum of dependencies you would get if you did a random ordering of the words in the tree. And as you can see, and this is a result that I said has been confirmed for all the tree banks we have, as you can see, languages are not optimal, but actually they're a little closer to optimal than to random. They clearly have a phenomenon of dependency length minimization. And I don't know if you can see it, but Caesar and Cicero are BC, and then Peregrinatio and Vulgate were almost medieval Latin, they're much later. And then for ancient Greek, there is Herodotus, which is earlier, and New Testament that is much later. And the angle, the distance between the blue line and the red line gets narrower. And this is much clearer here in this log plot of the distance between the dependency length observed and the optimal dependency length for Greek. As you can see, it gets shorter and shorter. So there's a general tendency. And if you look at results published by other people, for example, for Italian is almost perfect. We can pride ourselves on having a minimized dependency, minimized language. It's very efficient language. So this dependency length minimization explains preferences in word order variation and shows a trend towards minimization across time. We've also shown that it's a good correlate for word order. And so we're now using it to study whether we can use these properties to predict the performance of parsers in natural language processing. And in fact, we can, and it gives a very good explanation of the performance of parsers. 5 minutes. If you want. Okay, yeah. No, I have two more things to talk about. Yeah. So I'll just go fast on. I had 2 more case studies. I constructed it in case studies so that I can basically stop at any case study. But so I would like to say something about how is this relevant to natural language processing. And I think it's relevant to natural language processing in 2 ways. We can tie the typological data to the corpus data, and that becomes relevant for natural language processing because we then find properties in the corpora in instances of the data that we use in natural language processing. So I'll briefly show you a correlation between what is known about of a property on large-scale typological data and corpus-based data. And this is something in the causative construction. The causative construction is exemplified in this example. Mary broke the vase broke, that's a causative. The first sentence means Mary caused the vase to break, and the second sentence is an intransitive that indicates that this event happened, this change of state event happened. All these causative have a notion of externally caused change of state. It's the reason why it's interesting to study typologically and corpus-based is that typologically it's very widespread. Almost all languages have this construction, and corpus-based is interesting because it's a very frequent construction. We find it with a lot of verbs in a lot of sentences, but not all verbs have this alternation, and across languages, not the same verbs have this alternation. So the fact that it is usual an externally caused change of state event is true, but not all externally caused change of state event have this alternation. There's variation in which verbs can exhibit this this construction. And there's also, so as you can see there, arrive, appear cannot be causative in English, but it can in Japanese. I can say, I arrived, this person. And the morphological marking is different in this construction across languages. So in English, there's no marking. In Italian, there is marking for the anticausative, for the intransitive. Usually, intransitive in Italian have the se, fake reflexive. That is typical of Romance languages. Japanese marks both in different ways. Mongolian marks the causative. So there's a difference in what of the 2 sides of the alternation is marked. So which is requires more information. So the question we could ask is, is there a component of meaning that determines a causative alternation? Is that why certain verbs have a causative alternation and other not? Is there a component of meaning that determines the marking? And what are the quantitative properties of this component of meaning? So Haspenmath, a well-known typologist, has proposed that there is a quantity that he calls spontaneity that quantifies, that is quantified by variation of a number of languages that are marked with the anticausative and the number of languages that are marked with a causative. So for the same verb across languages, is the causative or the anticausative that is marked. That seems to be, if you take this simple ratio, that seems to put the verbs in a language on a scale that goes from those that are the most likely to be spontaneously caused, so a change of state that happens for some internal cause, to a change of state like freeze, to a change of state that requires an active external causer like close or open. Now, the same question can be asked for corpus data. Do we have this underlying property? Do we find a corpus correlate of this underlying property? So, for example, if we calculate the frequency of the causative use and in the anti-causative use, do we find the same scale? And the answer is yes, this is a correlation. It's a bit spread, but it's a good correlation. So that leads us to think that there is an underlying component of meaning of these verbs that we can call spontaneity, we can call probability of having an external cause, or it depends on the theories, that generates these two different epiphenomena, these different properties that we see on the surface. This has been confirmed recently by Aspelmath, by other on 6 other languages, and we have done an interesting parallel corpus study. What happens when you're in a parallel corpus? If you put these verbs in a situation in which you control the pragmatics and the semantics, so the translation should have controlled semantics and pragmatic, and also pressure for keeping the same construction, but you change the level of spontaneity of the verb, you actually find an interesting effect that if you put a spontaneous verb in a transitive construction, it tends to be translated as an intransitive. So it goes back to the more congruent syntactic structure that is more congruent to its lexical semantic meaning. And if you put a non-spontaneous event in an anti-causative, intransitive construction, it tends to be translated as a transitive construction. So there's a pressure to regularize, to make congruent the syntactic structure and the lexical semantic structure, and that has to be explained not just by surface frequency, as Aspelmath wants to propose, but by some underlying lexical properties. So this could be useful, for example, for machine translation, I think. I want to very briefly say one more case study. I'll do it super fast, but I think that for the NLP people in the audience, this is interesting. And this is kind of the opposite use, using the surface of languages to annotate each other. So we have all these statistical approaches. We're starting to understand the quantitative properties, but they still rely heavily on hand annotated corpora, which we have. But as we move, as I said at the beginning, we see more and more languages. We need to start thinking about not annotated corpora, or at least partially annotated corpora. And there, an interesting thing to do is to use languages to annotate each other. You put them in a parallel corpus situation, and you use one language to annotate the other. And I want to illustrate this with the problem of event duration. If I have to determine if an event is long or short. So John entered the president's office, the president woke up is fast, and that allows me a causative reading of this sequence of events, which is not allowed in the second example, because the duration of clicking is pre-existent entering, and it's longer than entering. And this is very relevant for generation, summarization, information extraction. So there have been proposals that are based on context, and I'll illustrate here again a proposal based on lexical semantics. There are languages that express event duration, perfectivity, boundedness of verbs overtly, especially Slavic languages. They have this complex spectral system that tells you the same verb, cook. If you use it nakedly, let's say, it's an imperfective. If you add a prefix, it becomes perfective. It means a short event. If you add a postfix, it's perfective. If you add a prefix and a postfix, then it goes back to being imperfective, but with a resultative meaning. So you can use these prefixes and postfixes as indication of the aspect of a verb, and you can use it then to annotate the English and tell you if the event was long or short. So you can do this is a really trivial probabilistic model. We have used Serbian to annotate English. And as I said, we did it with very simple annotation to just if the prefix was present or not, and if the postfix was present or not. So not even the lexical information, just 2 features and 600 examples. And these are the results. BNet is us. And Gus and Pan are other people from Stanford that did the same problem. As you can see on an out-of-domain data set, the Wall Street Journal, which was not the domain on which we trained, we have the same performance. They had 10,000 examples. So clearly, I just want to conclude on this. Clearly, having linguistic information is useful. It can greatly reduce the amount of information we need to annotate. And it makes clearly the prior of our models much stronger and so more predictive. And as a final comment, this is an interesting method because it goes from a poor resourced language to a rich resourced language. So even poorly resourced languages, if they have the right linguistic properties, they can be very useful for any kind of use. So I think that studying computational method for linguistic problems is clearly useful. It gives us methodological added values. It's formal and it allows to test the predictions clearly. It has great descriptive validity through the use of corpora and large samples. And I would suggest to the linguist in the audience that we should just do methodological leapfrogging. We should just skip the experimental stage of the discipline. There's a lot of interest in experimental methods. Computational methods are modeling. If you look at disciplines that have been experimental for a long time, they're all moving to modeling rather than experiments. I think we should use the same. Computational linguistics is a next generation linguistics. Thank you.
Thank you for your very interesting talk. There is time for some questions.
Okay, thanks, Paola, for the wonderful examples of how we can use computational analysis for answering non-trivial and very important linguistic issues. So, two questions. On the first one is on your first case study, so on Universal. So you're talking about frequency as number of languages, right? So I was wondering whether another important aspect would be to consider the fact that in the same language there could be possible alternatives, orders that are available, but with different frequencies in a way. So we want perhaps another parameter is not so, let's say, the type frequency of the constructions, but also the token frequency of a construction. And the second aspect is what you use about, I very like the example of Latin, of course, but you see, perhaps I missed the point in the sense that you said that the dependency length minimization is a correlate of free word order. Is a positive correlate or is a negative correlate? In the sense that it seems for you that going from Latin, from early Latin to medieval and let's say Italian, there is an increasing of minimization, which on the other hand, it seems that we go from more free word order to less free word order. So
yeah, okay. Yeah. So it's a negative correlate. Yeah. So it's correlated, but it's a quantification of freedom of word order, right? And so if you have more dependency length, you tend to see more freedom of word order because you have more of these mixed phrases. That's why I chose that example. If you saw, you really have a modification inside between the adjective and the noun phrase, a modifier of the verb that is inside the noun phrase, the noun and the adjective. And as for the first question, absolutely, that's precisely why we're doing these dependency length minimization studies. We're trying to look at how does the variation inside the language play out. And I haven't done the two together in the sense that now what we could do, since we have corpora, we could put the two together and study. I plan to do it. So the typological notion is based on the notion of dominant word order. And so we have no indication of how dominant that order is, right? So there are a lot of confounds there that should be included in the models. We should include modeling how dominant the word order is, and also how for example, syntactically determine this. In German, you have 2 word orders, but they're completely determined syntactically. You have a medial word order for the main sentences and the verb final word order for the subordinate sentences. So the models need to be more complicated. And that's where the computational linguistics comes in, because we have the large size of languages with the different tree banks, and we have a large sample within the language, so that you can study the two. You could have a hierarchical typology distribution. That's sort of the idea I'm thinking about at the moment.
Okay, there is time for another question.
As you mentioned, one possible application is machine translation, because that the reordering problem is one of the major issues. So but there you need to learn the mapping of the ordering one language to the order in another language. So can you comment on that? I mean,
well, obviously the statistical machine translation systems work very well, but this information could be useful if you need prior knowledge because you don't have enough data, or if you want to skew your data a bit differently, more information on the reordering. The reordering now, it's a very hard problem, the reordering, and it's down in a very only with information of the surface structure. We basically count the number of words we need to skip to reorder. A dependency length minimization approach could tell you it's based on the structure of the tree, and so it could tell you it could give you a different measure of distance. For example, I haven't tried it, but maybe that could be useful.
Okay, thank you. Now we have a session. Alessandro Lenci is the chair.
No.
Bene. Bene. Vedo che seguite le istruzioni alla
Okay, so I will ask Giovanni Colavizza and Frederic Cabrio. Okay, ciao.
And Giorgio Guzzetta is ready for the next presentation.
Sorry, I forgot. I don't do this one.
Okay, so I followed. You are the second one, right? Okay, great. Okay, 15 minutes, right? Okay, we follow your instruction. Perfect. Okay, so we are now entering the heart of the conferences after the wonderful talk by Paola Merlo. So the first session is on NLP and digital humanities, NLP and social media. So I welcome Giovanni Colavizza, who is going to talk us about the mining citations to primary and secondary resources in historiography. So you have 15 minutes.
Thank you very much.
Questions included.
Yeah, okay. So, good morning, everybody. My name is Giovanni Colavizza. I'm a PhD student at the Swiss Federal Institute of Technology in Lausanne. And as the first PhD student in line after the keynote, so I'm afraid we will move from universals to particulars with this intervention. So my topic is mining citations into scientific publication in history as a domain. Let me start by a little bit of motivation. Why are we doing this thing? So if you imagine to be a scholar in 2 fields, randomly picked, history and computer science, and you want to collect the state of the art for your research, well, you are in a quite different situation. A computer scientist nowadays can rely on extensive services that are based on citation data, which is extensive and is reliable. It is really not the same for a historian. Okay, you can try to use the same services. You can try to use Google Scholar, Web of Science, Scopus, but the coverage is not comparable. So in the end, you are back again to the traditional methods of bibliographical lookup. So there is a need. Next, there is an opportunity and a challenge. Citation that we are interested into usually happen in footnotes, not as a reference list at the end of the publication, meaning 2 things. One, that potentially the semantics of this citation are richer. So we can classify this citation, we can qualify them, but at the same time, it's much more challenging to extract them, of course. And lastly, humanists traditionally refer to what we call primary sources, so some kind of evidence. Might be the object of study, or for a historian, evidence close in time and space to the event under investigation. For historians, normally these are sources at an archive. Okay, so we really don't know much citation-wise of the use of these primary sources, but for specific domains, for example, classics. So these are our motivations to start a project called Link Books within the broader context of the Venice Time Machine, which is a collection of projects with several partners in Venice. This project has the aim of digitizing, extracting citations, analyzing, and building services about the history of Venice, regarding citations, of course. At the moment, we are quite advanced in terms of corpus collection, I would say. So digitization is almost over, and the annotation is ongoing. We have sufficient data to really try to experiment this citation extraction. And as I said, we ambition to enlarge a little bit the scope of the project. Citation extraction and creation is just one of the steps. Another one very important is building services for the community and eventually analyze this data. So there is a field of bibliometrics that could use some more research related to humanities. So to go to the actual techniques, okay, the juice, we developed a 3-stage pipeline for citation extraction. First of all, we want to filter out the input space. So we want to detect footnotes. We want to detect the narrative space of footnotes because, I mean, footnotes can span multiple pages. So we really need to individuate that space. Secondly, we want to perform citation extraction, which means finding each citation within every footnote, so boundaries. And lastly, citation parsing, which means considering each citation and classifying every word or token inside that with a category, say the author, the title, publication year. So how does it work? Well, the first step, we approach it with a very, I would say, lightweight supporting vector machine classifier. We consider text, lines of text, and a very lightweight set of morphological features. Okay, we also want to be language independent if possible, because we have a corpus mainly in Italian, but also English, Spanish, and what else. Okay, and I mean the results are encouraging. We could also, I mean, we could of course refine, but I would like to point out what are the how to say the most important problems that we are getting. Okay, so here in this case, the biggest problem are partial citations. So citations that are very reduced in form and make reference to another extensive citation within the same publication. Okay, we know how they run. I mean, EBID, EV, and all that kind of things are very difficult to use in order to understand if they happen in a footnote or not. Next step, we move to graphical models, so conditional on the fields, and we work on tokens, words, with the goal of essentially having a binary classifier and saying if a token is within a citation or not for the text stream into every footnote. And furthermore, we want also to try to distinguish tokens are pertaining to a citation to primary sources or secondary sources. Here, the feature set is much more broad. It moves from morphological to syntactic and semantic. The results, I would say, are encouraging, especially because we are able to maximize recall, which is what we look for at this stage. But still, I mean, there is a big problem because if you misclassify, so it's very important to have high accuracy at the instance level, because if you misclassify at the level, essentially you end up with multiple citations, even if you should have one. Okay, so what we will look for as a next step is to perform begin-end classification and try to see if that is going to improve the accuracy at the instance level. And lastly, to do citation parsing, we use the same approach. So we consider footnotes as a temporal series of words, essentially. But here the task is a bit more challenging because we have a broad set of categories, nearly 50 categories that we use, and a larger set of features. So again, quite good results overall, but with a couple of problems to solve. One is the semantic ambiguity of classes. Okay, it's very easy for the model to mistake editors or curators into authors because they are similar in the feature space. But also we have a skewed training set, essentially. Not all categories are represented with the same numbers. We have a lot of authors. We have not a lot of Filze and Faldoni for archivistic terminology. Okay, so this is something that we need to fine-tune. And to conclude, of course, once you assume to have citations, you still need to perform at least two basic, very important things. One is normalization. So you need to have a canonical form for every citation into a publication. So to say, expand those EBID and EV that I mentioned before, and to perform linkage. So you need to link every citation to a unique identifier into a catalog. And these are the next steps for the coming months, at the end of which I hope we will be able to publish the data and work on that. Thank you very much.
One question, which is concerning the errors of your classifying
different pieces of the citations. I mean, yeah. So you report the maximum confusion between things that belong to the same semantic categories, if I imagine. So author and editor and so on.
Yeah.
Yeah.
There is some confusion, exactly.
Yeah. Have you tried to? I mean, because some of these look like, apart from also kind of name entity recognition task, in a sense, at least for distinguish author from place, yeah, or for others, or I don't know, publishing house is, yeah, a kind of organization. Have you tried? I don't know.
Not yet, but it's planned. I mean, I've mentioned that as lookup features. Mm-hmm. So essentially, yes, it's a good point.
Yeah.
Okay. Absolutely.
Roberto?
I see that you switched from SVM to conditional random field classifier. Why this choice is a sort of a complexification of your modeling task? So what is the main reason? And did you try models with more features that you mentioned you exploit with CRF?
At the first step.
In the first step with SVM.
Yeah, but I mean, with the features that we had at the time, so now the situation is has a little bit improved. But with the features that we had at the time, it wasn't making a significant difference. So we settled for the simplest possible model and set of features. Essentially, that is the quick answer. We will, yes, because we have a new set of features. For example, graphical features, like italics, bold, etc. We didn't have back at the time. Now we will introduce, and I hope it will make a little bit of a difference. It should, at least. Not yet. We are doing that. No, it's not part of this publication.
No other questions? Okay, we can thank our speaker again.
Thanks a lot.
Now we welcome Giorgio Guzzetta, that is authoring with Federico Nanni, paper on computing, memory, and writing, and reflections on early experiments in digital literary studies. Yes.
Okay, this is, of course, a collaboration between the digital humanists, which is me. Oh, sorry. Can you hear? This is a collaboration experiment work on between me, that I am a digital humanist, and he is somewhere there, which is more into language processing and natural language processing. Okay.
Yeah.
Right. I will do this. Okay. As from this quote from 1966 quote from Vittorini shows, our relationship with the past through memory is changing in these years. Vittorini in Le Due Tensioni wrote that technological progress can also be liberating. For instance, with the creation of a macchina assoluta, and he is referring to the Turing machine, in which man can fully transfer the mechanics of human nature, starting with the memory-related part of our thinking process. How this is happening and where we are going from here is, I think, a critical issue for digital humanists. Digital humanities, I mean, the use of computers for humanities, as the first talk shows, is started very early, 70 years ago or something, but only the last 10 years, the presence in institutional presence of what we call digital humanities grew stronger and became an established academic research area, if not a discipline altogether. The network of digital humanists, as we can see, is slowly conquering the whole planet. But as one of the greatest experts on web worldwide once said, with great power comes great responsibility. And we need some sort of safety net to build upon which a discipline like that could be based. And one way to do that was to have a closer look at the history of humanities computing, the name that was used before, digital humanities. And there were different attempts, but for a number of reasons, this proved to be a challenging task, mainly because it was a plural history involving both sides of the oxymoron, humanities and computing. Seeing them as two stable and distinct objects, reifying them means obscuring the complex and interdisciplinary nature of both things. Before moving on to specific, the case we are presenting here, just quickly mention that this paper is part of a broader project on histories of humanities computing, and these are two things that I'm doing now. One is a wiki which have a lot of collecting material in the pre-web period of humanities computing, and the other one is the same thing but only a bibliographic group in Zotero with the same idea. And of course these are I'm just notes that I'm taking, so it's free to share, and even if someone wants to add something, it's free. I mean, I'm very happy that someone wants to do that. Now, talking of what we are trying to do. Okay, this is not how it was supposed to be. Anyway, this is the page that of the case we are studying in that website. Well, you can see that the text is a bit mixed up, but anyway, the case we study, we focus on an experiment on the influence of Milton's Paradise Lost on Shelley's Prometheus Unbound. You can have more information if you go there about the people involved, the kind of computers, etc., the programming languages, etc. And I was not able. Okay. We think that this experiment was very interesting for a number of reasons, especially because, first because it's one that is well documented from the start. In a conference, in a New York conference of 1964 on literary data processing, possibly the first one about these kind of problems, there were two papers on this project. One was by the main investigator was Rabben, describing the aim in using computer, and Rabben was a professor of English at Queen's College. And the other one was by the people that actually wrote the program. So it's very specific, more technical issues there. And it's very rare that we have all this kind of information on these early projects. So that's one of the reasons. And this combines, in this case, we can combine all the different histories that we are talking about. One was humanities computing, because Rabben was one of the first humanities computing scholars. And if he was the founder of the first, and for a long time, the only journal of humanities computing in 1966, I think. Then literary studies. In literary studies is interesting because the notion of influence became an important one in the 70s, when mainly thanks to Bloom's idea of the burden of the past and of the side of influence felt by writers from the 19th century onwards. The main problem of both Rabin and Bloom was how a poet shaped the linguistic memory from reading earlier poets and how he used it to write his own poems. The problem is not so much with the past in itself, but with the ways in which this past language is mediated, and with the fact that memory and tradition was becoming more and more external with computers. And well, this is a very complex issue, and I don't have time to get on this, but if there are questions later, we can discuss it. Then there is computational linguistics. The programs that they used were an adaptation of earlier ones used in machine translation. Now, I'm not an expert on this history of machine translation or language processing, etc. But the fact that at that time they were able to conceive machine translation programs when they didn't even have a shared encoding system to put words into computers is a bit puzzling for me. What kind of idea of translation they have? I suspect that it was kind of problematic one, to say the least. But you know, I'm just a literary scholar, so maybe I'm well. And then computing. It seems that between 1966 and 75, and there are documents about both this period in this same research, they changed machine. They moved from an IBM 7044 to an XDS Sigma 7, and they changed also programming language from assembly level FAP, which I don't have an idea. I have no idea what this is, to Fortran. When, how, why, and that, and what it meant for the experiment are kind of questions that should be addressed, but they are not yet. Okay. So this is a bit of prehistory of early humanities computing experiments, and it starts in 1935 when a professor of English at the University of Illinois, his name was Fletcher, Harris Fletcher, I think, says, and this is from a book a manual by IBM on using punched card system method for research in academia. He says about literary studies. For several years, the need for a word index of Milton English prose work has been apparent. The preparation of word indexes and of concordances involves a great deal of manual labor. To overcome these discouragements and to increase the degree of accuracy and investigation was made into the possibility of using the new alphabetic tabulating equipment in connection with index work. This investigation resulted in the adoption of the technique as described in the following page. Well, I'm not sure, but I think this is the first time that something like that was put on paper. And again, in 1936, so in 1949, then there is Busa that is visiting this, the IBM, we all know that Busa was the first one who did concordances, etc. There is no, and when he said that, was speaking in 1980, speaking about that, he says, although some say that I am the pioneer of the computers in the humanities, such a title needs a good deal of nuancing. And on the stacks of the IBM library in New York City, I had spotted a book, and I'm thinking that that one might be the book he's referring to, whose title I have forgotten, which was printed sometimes between 1920 and 1940. In it, someone mentioned that it was possible to make lists of names by means of punched cards. So Milton words, because the thing that I'm interested in here, that it's the same kind of people that Milton was already punched in some way. And the experiment of Rabin might have been part of this tradition of what I call punched card humanities. Okay. These are the two people that were doing the program, the software. And this is interesting. The article is interesting because it uses a language that is a bit strange for us. So I just tried to transfer that in a more modern language. And the steps were creation of a word list, that means a single word list, that means tokenization. then reduction to a canonized form in which each word was reduced to its root, lemmatization, and then elimination of trivial words, which are called now stop words. And then it did detect similarities between sentences. Documents were then after detecting similarities between sentences, documents were then merged in a combined sentence term matrix. And the last one, the results were ordering following the number of common words between two sentences from different books. Now, the fact that they used sentences instead of lines, because in both cases it was poetry. So traditional concordances was made on lines. They had to redo the whole process using sentences instead. And that's interesting too, I think, for an historical point of view. And I don't have really a conclusion, but I leave you with three questions that were asked by Raben in his paper. And the three questions they were trying to explain why he was using computers. It says there are these ones. Yeah, I finished. And I think they are interesting if we think of this in the post-human kind of situation we are discussing now. Are machine matching humans? And in that case, he said yes, because all of the connections that were already established by other critics, human critics, of course, were there. The second one, do machines outperform humans? So they do add something. And even in that case, it's yes, even though it's a bit more complicated because there are a lot of weeds and noise to be filtered. And this was done by humans. And this is the way how the next step we follow is that we try to understand how this could be done better. And we used, for this reason, okay. Well, yes, I mean, we tried some new techniques that were not usable at that time for this. So, yeah, well, basically, this is our project.
Okay, thanks. So, I think there is time just for one brief question. So, I can, well, I have curiosity for this, and so I would like you
to use maybe the question time for tell us a few words about what is exactly this new technique that you are trying to apply. But
do you want to say, because he's the
please
the one.
Be very brief.
Yeah.
Basically, the problem that we detected in their method was that they were just counting the number of words in two sentences, one in Milton and one in Shelley. And so basically at the end, they got up the longer sentences. That, well, it's obvious for us, but so we used TF-IDF. But at that time, TF-IDF was not invented. It was invented like, well, the IDF part was invented 7 years later. So we started with using TF-IDF and then cosine similarity. But the real problem is that, well, you have to do evaluation on that. So now what we want to do is like annotating paragraphs and sentences that are relevant for us and they are similar in both authors. We want to see if with the FIDF and cosine similarity we can get out that. And what else we can get out. So these are the next steps. And also look at, co-occurrences and using some method in text reuse in order to detect these kind of things.
Okay, so that's an interesting example of how techniques that have been developed outside the field of humanities can be applied used to answer questions that were not answerable.
In 1963.
So that's an interesting, let's say, interchange of and interaction between these two communities. Thanks. Okay. So this is the end of the first session, and now there will be a coffee break, and I think an announcement by the organizer.
A couple of technical information. So coffee breaks, lunch breaks, poster session will take place outside of this room, so in the big hall. And we ask you to upload your slides during the breaks because we are live streaming the presentations, and so we need to have all the slides here in advance. Thanks.
Welcome again. My name is Francesca Chiusaroli. I want to thank the organization for organizing this, for including this area, web and social media, at the conference. And I want to thank them on behalf of my co-chair, Daniele Pighin, who is not here. Let's start then. The first speech is by Stefan Richter, Andrea Cimino, Felice Dell'Orletta, and Giulia Venturi, and the title is Tracking the Evolution of Written Language Competence and NLP-based Approach. Thank you very much.
Hi. So
12 minutes
yes.
for presentation.
So I am Andrea Cimino, and I am one of the members of the Italian NLP lab of the Institute for Computational Linguistics in Pisa. And what I will show you today is one of our latest works, and is a system to track the evolution of written language competence of L1 learners using their written productions. In particular, I will give you a small background on the topic. Then I will explain you the aims of the work. I will give you also a small overview on the corpus. Then we will see the approach that we used to develop our system. We will see the experiments we have done. And finally, we will see the results. So when we have to deal with the problem of tracking the student evolution concerning their writing skills, in literature, two different approaches are taken into account. One is the analysis of the form. That means we are studying the linguistic features of the document. That's why we study usually grammar, lexical, and syntactic features are taken into account. And one is the analysis of the content. That means we are trying to understand if the students are answering correctly or not on the essays. So both of the two scenarios suffers of the same problem. That means that usually the essays must be manually graded by the teachers. So another problem for the Italian language is the fact that there is the lack of the resources. So that's in our work we try to supersede these issues, and in particular we have to remember that in our work we are focuses on the analysis of the form. In particular, our system does not rely on graduated productions, then exploits linguistic predictors, and also is based on supervised machine learning techniques. Another aim of our work is the identification of the most discriminative features for this task. So let's see together the corpus that we have used to develop this system. The name is CITA, it's a recently developed corpus. That means Corpus Italiano di Apprendenti L1, and is composed of more than 1,000 essays written by more than 150 lower secondary students from the 2 different years. In particular, these essays are collected in 7 different schools in Rome, 3 of the historical center, and 4 of the suburbs. Another important key feature of this corpus is that all class prompts are different, for the exception of the last text of the first and the second year, that we call prova comune. The documents are annotated with the chronological order of the students' essays, the student background, and the errors and the corresponding correction by the teachers. We have to remember that the essays are not scored. So our approach basically exploits the following assumption. That means that given a couple of documents written by the same student, usually the second document should show an improvement for what concerns the language competence evolution. That's why we explain this assumption. We built a 2-class classifier that, given in input 2 different documents written by the same student, assigns 1 if the first document was written before the second document, or 0 in the opposite case. And our classifier uses linear support vector machines as a machine learning algorithm. So what we do in the training phase? In the training phase, we collect all the documents written by the same student, and we generate all possible pairs and this will be the training set, the documents on which we will train. For each document, then we generate a feature vector, and now the training sample that we will give to the classifier is the difference of the vectors of the corresponding two documents. Then on these training samples, we will train the a model M, as said, trained on these collecting training samples. What we do in the classification phase is that obviously given two unknown documents, we compute again these feature vectors, and we use the previous built model M to classify whether the X was written before the Y or not. So let's have a brief overview of the features used by our classifier. The features are of two different kinds. The first kind are the one that comes from the automatically extracted features, because we used from the raw text, we post-tagged and dependency parse all the ESAs. The features that we use are commonly used in many different tasks like authorship attribution, readability assessment, and so on. The other different kind of features are the one that comes from the fact that corpus is that CITA is a corpus, manually annotated corpus. So we have three different kind of errors that are grammatical, orthographic, and lexical features. So for what concerns the raw and lexical features, we consider the average and sentence length, average token and sentence length, the distribution of words in the basic Italian vocabulary, the average frequency class of dilemmas, and the type token ratio. For what concerns instead the morphosyntactic features, we considered the distribution of part of speech, the lexical density, and the verbal mood. Instead, for what concerns the syntactic features, we consider the distribution of dependency types, past retyped features, some verbal predicate features like the arity average and the number of verbal roots with respect to the total roots, and some subordination features like distribution of subordinate versus main clauses. Instead, for what concerns the annotated errors features said before, we consider three different kinds of errors, like the grammatical errors, such as wrong use of verbs, preposition, or pronouns, the orthographic errors, such, for instance, use of terra instead of terra, or the misuse of terms, that means the lexical errors. So we made different experiments for different experiments, where we used six different schools for training and one for test. The experiments were set four, where the first one where we use all the possible document pairs that can be generated from the documents. Another one is the experiment where we use all the document pairs such that were written in different years. Then the penultimate experiment is the one where we consider the first and the penultimate document written by a student, and the last one is the experiment where we consider all the pairs where the pairs that have the first document and the last document written by the student. That means that belongs to prova comune. So using the person correlation analysis, we were able to find the most discriminative features that allow to capture to track the evolution of a student for what concerns their language skills, writing language skills. And we found that the most important feature is the frequency class of verbs and the percentage of auxiliary verbs in the first person plural. And for what concerns instead the manually annotated errors, we found the lexical errors per word is the most discriminative features. Then, let's discuss a bit the results. As I said before, we made 4 different experiments, and for each experiment, we used 3 different configurations. One that uses all the features that we described before, another one that considers feature selection, and another one that considers the feature selection plus the manually annotated errors. As we can see, in an upper part of the table, we can see the experiment with all the texts. In particular, there the results are not very good. We are going about 60%, but because for the classifier, that's why, because the classifiers there are low margin for discriminating, obviously, if the documents were written before or after. Where we consider instead different tiers, the results are getting a bit higher. We're going about 65%. Where do we go? We study the first and the penultimate text. We go around 80%. That's a very good result. Instead, when we analyze the first and the next text, we are in the best model. We have 90% of accuracy of F-scores. Sorry, and the most important thing to consider that this result is sketched through the all feature model, but that's most probably because the classifiers is able to understand that the second document belongs to the prova comune, most probably of F fits. So we should consider more the feature selection plus error configuration. So in summary, we introduced an innovative evolution tracking system based on set scores. We used for the first time CITA, that is a corpus of essays which have been manually annotated with errors, and we have shown that with simply 9 features, which include raw, lexical, and static features, we are able to capture the written language competence evolution. So thanks for your attention.
Thank you very much for perfect respect of time.
Two questions, one simple and one more complicated. So the first question is that in your classifier, you use the difference of the two vectors.
Yes.
And that is somehow has an effect of...
Sorry, just a second, I will...
Yes.
Yeah.
That could have an effect of dropping some aspects, of the document. So that the first question is why? Have you tried, using both vectors instead of the difference?
Yeah, we made different experiments. We the point that we use the difference of the vectors because to avoid overfitting. Because if you know the real values, most probably we overfit on the documents. Instead, if we work just on the difference of the documents, these problems are less visible. Let's say. That's another. That's a point.
Yeah. The second question also related to risk of overfitting, because if you take in the last.
That's why we have shown that in the last in the prova comune we had most probably these problems of overfitting.
Yes, that was my question. So maybe the last prova comune is different from all the others.
Yes.
So the classification and showing that it's different from the others is easier than other tasks. So I wanted you comment on this.
Could you please?
No, I think we agree.
Okay.
The prova comune, the last, is somehow different from the others. So it's easier for the classifier to detect.
That's why we, with the all features configuration, we obtain this such good result.
Any other question?
So text length is a rather well-known feature to discriminate between not so good and good writers. So my question would be, have you tried to sort that out? So to see what stays constant, or what of the other features have the most impact, rather than using this one, which is already well known to be very helpful?
So can you please
did you try to remove text length, sentence length, from your feature vector,
and check which was the results of the classifier? No, so this experiment we haven't done these experiments. We first, as said before, we used this person correlation, and we try to train this on this 9 feature, and then on with respect to the all features.
Yeah. So sorry, just a quick follow-up. The person correlation does not. This sort of works on the same data set, but it's not directly connected to what the support vector machine does. So even though there is sort of hopefully a relation between the two,
because we have the interaction of features that the obviously SVM considers.
Yeah.
So what we should do most probably is to understand how to improve, and with support vector machines we should try to make feature selection through SVM, maybe trying to remove features to check which is the best approach, but we may see this is simply a pure analysis correlation. So the most probably thing which run all the configuration, or better, try some good algorithm to prune the features, and let's check which are the most discriminative features for SVM.
Okay,
so
thank you.
I'm interested in length too. What is length in this picture? What about the length of the sentences? Length
how
is
long?
one of the parameters.
Yes.
Length in
how much longer or
is a quantitative parameter.
No, actually, now I don't remember this. The values I don't remember, because we made experiments, but I don't have the values. But okay. But these are, I think, that they're in the papers.
Thank you very much. If there are no other questions, so we can go on with the next presentation.
So, thank you very much.
Thank you very much. The next speakers, Mirko Lai, Cristina Bosco, Viviana Patti, and Daniela Virone, building a corpus on a debate on political reform in Twitter.
Thanks, Francesca. I'm Viviana Patti, and this is a joint work of members of Dipartimento di Informatica in Torino and Daniela Virone from Dipartimento di Studi Umanistici. In particular, she is a PhD student. She is a PhD student in Linguistica Francese, and this is the reason the focus of the corpo is on French language. In this paper, we basically collected and analyzed a corpus for sentiment analysis and opinion mining, a Twitter corpus. This is the focus, and the topic is a debate about political reform. In particular, Daniela was interested in the debate about gay marriage, mariage pour tous in French, and it was very interesting to see for us that we are working on corpora on sentiment analysis for many years, to see how with this particular topic, a debate on political reform could be interesting to reason about the classical polarity labels, but of course also on labels which could be related to semantic areas or aspects of the reform that somehow was the ones that the user were commenting, expressing their opinion. So we will go for a finer grainer annotation of the sentiment in this kind of corpus. And we were also interested in the aspects related to figurative language, or also to see if this kind of devices are present and in which way in this kind of communications related to this topic. So I will, a quick overview, will give you some motivations about our work, and I will focus mainly on collection, analysis, and annotation of the corpus Twitter mariage pour tous. The wide context, of course, is social media in this session in general, and also in our work. In social media, of course, users are encouraged in sharing their views, and they regenerate a large amount of social data, and that was true also for the kind of debate we were analyzing. And for us, this was a great opportunity to investigate communicative behaviors, and also different conversational context that came from also different media and context where the debate on mariage pour tous was conveyed in 2013. That was the year where mainly the reform was proposed and discussed, not only in the parliament but also in the society, in the French society. And in particular, if the wide umbrella is the sentiment analysis and opinion mining, we can say that in this case, another aspect that emerged and which is in tune also with a new interest in the semantic, in the sentiment analysis community, is the aspect of stance detection. This year, for example, in Semeval, there is a new task in the sentiment analysis track, which is stance detection in tweets, which is really related with what we are doing, because the task is to automatically determine if a text, if the author of a text is in favor, against, or neutral respect a topic which is usually chosen as a controversial one, which is because it's interesting to see how opinions are polarizing on these controversial topics like mariage pour tous, but there are many other interesting topics from this point of view. And about the approach that we decided to apply to this data set, it's holistic in the sense that we decided to take into account linguistic aspects, of course, related to figurative devices or use of hashtags, which in Twitter is relevant. But also, we carried on a non-linguistic analysis related to the usage of the hashtag, behavior of the users, and so on, especially from a quantitative analysis perspective. And the topic was mariage pour tous, but I just wanted to mention that we decided to test our methodology also on another Italian dataset that will be presented in the afternoon by Marco Stranici, which is La Buona Scuola. And here again, we have a controversial topic. Most of you know the subjects because it was a controversial topic in Italy in the last year, in 2014. And again, we tried to collect data from Twitter and to apply all this quantitative analysis and annotation for this kind of debate. So the next step for us now is to make a comparison between these two corpora and these two analyses that we could do. And what we expect, we expect to come up with some semantically data-driven finer-grained annotations, and we will see what I mean with semantically data-driven. This aspect concerns basically the kind of topics that are discussed in the datasets during the debate. And of course, it will be interesting also to see relationships between communication, dynamics, and sentiment, and also to improve the knowledge about the context in which these Twitter communications are occurring. Collection. Since Daniela was interested to see many aspects of related to this debate, we collected actually not only a Twitter dataset, which is the one I'm talking today, but also data from newspaper about the mariage pour tous debate and about the parliamentary debates. So a future work for Daniela will be also to see how to analyze the debate and the communications in the other in the other corpora that we still didn't process. For what concern mariage pour tous, this is the time lapse, and we were filtering the data by using the hashtag mariage pour tous. That was by analyzing the life of the hashtag, we could somehow do also some historical analysis. In this case, it is not common to be able to do it, also because you don't always manage to collect all the data you need. In this case, Daniela was lucky and she could retrieve also this information, so historical information about the birth of the hashtag and the path of the hashtag, which was increasing in frequency during the debate, and also, as I told, contribution of users, analysis of which were the users, the politicians, and also other normal citizens that could contribute in the debate, at least in Twitter. And we could, for example, detect the fact that somehow there was an event in September 2012 that was the interview of the Minister of Justice, Taubira, that was particularly relevant for the growth of the debate, at least on Twitter. So we really noticed that the frequency of the tweets using the hashtags was increasing after this event. And the other thing that we did before the annotation, by analyzing the data, was to use some community detection algorithms in order to try to extract automatically some areas which could be the one somehow on which the opinions of the tweeters were collapsing. And these areas, according to this automatic analysis, were family, debate, right, and manifestation. And it was nice to see that when we went to annotate manually the corpus, we decided to select tweets from this very huge corpus with particular patterns, like the verb être with the hashtag in right or in left of the verb to be. Just because we saw that in this kind of tweets we could easily find opinions, really opinions about the topic. And we decided to apply classic annotation for polarity and figurative language, classic at least with respect to Sentipolk, that was the sentiment analysis task that we had for Italian last year. But we also tried to use the automatically extracted areas in order to label the semantic area topics and so on. And it worked. I mean, the manual annotators, they had also the possibility to tell that the topic was something else, but most of the time they could find useful the use of these labels. I think I have to conclude. So that's the good slide. In the future, we would like, to further validate the methodology to see if this kind of information that we annotate in this corpus and in La Buona Scuola corpus can be used for training classifiers, sentiment classifiers, and if the new information can be useful somehow also for addressing some new subtasks related to sentiment, like stance detection or aspect-based sentiment analysis, because somehow you usually speak about aspects in products when you want to say, if I like a car because of the color, but maybe not for the engine and so on. But we can think that maybe also a reform can have different aspects. I can like the reform from some point of view, but I don't like it for other aspects. And so this annotation of semantic areas could be really also exploited for a task like that. And last but not least, since we have this collaboration with Spain, recently we wanted to go for a new data set on a controversial topics, which is the independence of Catalonia, which is very hot now, currently in Spain. We collected the tweets, and in that case, there are also interesting issues related to the fact that there people is speaking in Spanish, but also in Catalan. also from a linguistic point of view, it will be interesting also to see if the sentiment is somehow also related to the language in which the opinions are expressed or whatever. That's all. Thank you.
Thank you. Are there any questions? One.
Thank you, Viviana. It seems that you are moving from a classical, let's say, positive, negative judgment to a more elaborated version, being in favor or being against a certain topic. Okay, yeah. So this seems quite interesting, and I was wondering whether you see any connection with the community which is working on argumentation theory. So trying to provide a structure, even a formal structure, to what is an argument in favor or against a certain topic.
Yeah, for sure. This is a very interesting suggestion, because also in this kind of sentences that we collected, where you have the verb to be, indeed you tell mariage pour tout is this, and maybe you put an argument also in order to, I mean, reinforce your statement. So for sure that's a direction could be interesting, very interesting to be exploited. Thanks for your comment.
Cristina Bosco said one question for one.
Because she doesn't want to hear my questions to the paper. No. No, the question is just an observation, in the sense that the example about the left and the right context brought me the idea that it would be interesting also for tweet analysis to start annotate information structure, which is typically something that for written language, especially in Italian and English, we try to forget, but it's typical of speech, spoken text. But I guess that for this type of issues, topic and comment or topic and focus will be very important issues, and especially the type of text will probably force particular pattern of topicalizations. Like, first of all, you say what you are against, or you express very, and then you argument on. And so also for the sake of argument structure, argumentation, this information structure will be relevant, and this type of text will be quite revealing for that.
Yes, also because in tweets you have something which is text, but it can be also similar to speech from many respects, as you know. So yes, thanks for your comment. It's interesting.
Okay, thank you very much. Next presentation, Sabrina Stehwien and Sebastian Pado. Generalization in native language identification, learners versus scientists. Thank you very much.
Hey, yes. Hello, my name is Sabrina Stehwien, and I'm from the University of Stuttgart. So I'm going to present a bit of work that we've labeled Generalization in Native Language Identification, Learners versus Scientists. And I'd like to start by having a quick introduction by presenting you with this written sentence in English. And I'd like you to have a look at it, and what you'd notice is that it's slightly ungrammatical. There's a bit of a word ordering problem here. If I were to tell you that the reason why this person made such a mistake is because this writer is not a native speaker of English, it's plausible, because this is unnatural for a native speaker of English to write a sentence like that. The correct way would be, yesterday Mary saw John. So you might be wondering, well, what native language does this person have? And you may come up with Italian, due to the word ordering rules being slightly different. And this is an example of language transfer, where a native language, the L1, influences the second language, the L2. And this is why we do native language identification. So in a spoken language situation, often you can identify the accent of a person, but in a written language situation, this is a bit more tricky. And so this is used for research in second language acquisition or for author profiling tasks. It's a fairly new field. Currently, the L2 is always English, and the L1 classes depends on the data sets. A typical data type that NLI is applied to are student essays for learners of English. And recently, good classification results have been obtained by using just simple lexical features. Currently, the challenges are the lack of good so-called learner corpora, and connected to that, the cross-domain performance. When you train on one domain or one corpus, the performance drops when testing on another. So our motivation here is we want to learn models or train models that learn instances of language transfer. But there's a problem here because it has been found that some data sets or some texts contain a so-called topic bias. And this arises when authors with the same L1 write about common topics, and this will point directly to their L1. So for example, in a sort of a language learning situation, authors may tend to write about their home countries or where they're from. So in a text by Japanese authors, if there are sentences like I am from Japan or I speak Japanese, then these tokens, Japan, Japanese, if they're very frequent, they may distract the model from language transfer features. So our contributions here are, the first is a bit more general. We want to see if domain adaptation methods provide possibilities of overcoming this topic bias and improve our cross-corpus generalization. Specifically, we ask, what are the effects on a novel type of corpus for non-native English, which are scientific publications? Because in an international research community, most of the authors are not native speakers of English. So this is our data. We use 3 learner corpora, the well-established TOEFL corpus collected from TOEFL exams, the International Corpus of Learner English, which is made up of student essays, and the Lang8 web corpus. This is a corpus that's scraped from the website lang8.com. It was proposed for use in NLI by Brook and Hurst, and this dataset is slightly more noisy because it contains web form entries. So our scientific corpus is collected from a subset of the ACL Anthology Network corpus. We labeled this data automatically by assuming that the L1 is derived from their domains of the author's email addresses. So we look into the headers, and if all authors have the same email domain, we use that document and assume that that domain corresponds to their native language. We move the metadata, so headers, acknowledgements, and reference sections, because these may point directly to their L1. And so this corpus is quite different than the others. We expect that NLI is more difficult due to the high proficiency of their authors in English and to the standardized writing style found in these publications. Also, the abundance of lots and lots of scientific jargon. So this is our very basic experimental setup. Our classes and native languages are Chinese, French, German, Italian, Japanese, Spanish, and Turkish. These are 7 classes. This is the intersection of our data sets. As a source domain, we use the TOEFL corpus, our largest corpus, and the other 3 is our target domain. So domain and corpus is used synonymously in this case. As features, we use recurring unigrams and bigrams due to the success that Buch and Meurels had while using these features for NLI. These are n-grams that occur in 2 different documents of the same class. And our classifier is the liblinear support vector machine with standard settings. We kept it quite simple. And then we focus on our domain adaptation method. So the first method is the so-called easy adapt feature augmentation by Haldome III. This method includes the knowledge of what domain a feature was extracted from. And I don't focus on the results of this method in this talk because the cross-domain performance we found was not increased on all data sets. So we focus more on the second method called marginalized stack denoising autoencoders by Chen et al. This is a more of a deep learning sort of neural network approach. It does not use the knowledge of what domain a feature was extracted for. It's completely unsupervised. And the intuition why it is used for domain adaptation is that we assume that the output of the intermediate layers provides robust feature representations across the domain. So we have a stacked architecture, and we assume that it simulates the situation of having features in one domain that are not present in the target domain. But what both methods have in common is that they modify the extracted features before feeding them into a classifier. So we use this as a pre-processing step for our features. So these are our four basic experimental situations. The first is a source-only situation where we train on the source domain, test on the target domain. The second is the target-only situation. This is completely in-domain case. Then in the third situation, we do a sort of a simple concatenation where we add a bit of the target domain data to the source domain as the first slightly domain adapted data sets. And then the fourth situation is where we use that same data, but then add our domain adaptation method. And these are our main results. So 1 to 4 are situations from the previous slide. And right now we're looking at the first column, the results on the ICLE corpus. This is classification accuracy. And we find that the results here are our best results. We found this is the most similar corpus to the TOEFL, so that this comes naturally. We go up to 98.9% classification accuracy using the MSDA method. Then looking at the other two data sets, especially for the target-only case, we found that the ACL appeared to be easier to model than Lang-8. But then when we add the domain adaptation, the situation is the other way around. So the results are good on Lang-8, but then worse on ACL. And this is because the TOEFL corpus probably overpowers the smaller ACL data set. And it's very hard to beat the target-only case for this data set, especially with the powerful MSDA method that statistically improves or significantly improves our results in all cases. And coming back to these language and country names that I mentioned at the beginning, we did an additional experiment where we just left these out with the stopword list and found that these did not have a significant impact on the results. So these cannot be the culprit. Okay, so we also looked at our features because we are interested in if our model is learning topics or not. And we did find features that clearly reflect language transfer, especially from the TOEFL corpus. For French and Spanish, specifically, we see words that are so basically the same in French and English or Spanish and English, but have different spellings. So this is definitely an instance of spelling transfer. Then concern and conclude are features that are highly frequent in French. And so the French authors use these by habit. In German, we see the typical onset of German adjunct clauses, comma, that, comma, because. Then for the ACL corpus, we found features that clearly reflect scientific jargon and also preferred research topics among authors from different countries. So especially for Turkish authors appear to like to do research on morphology, which is, I mean, plausible because Turkish is an agglutinative language and morphology is quite interesting here. And Spanish authors appear to like topics related to machine learning. So we conclude that the ACL appears to have its own form of scientific topic bias. So as a conclusion, number one, we found that domain adaptation improves our cross-corpus results on the learner corpora at least, and that our models do learn features that reflect language transfer. And we found that our ACL texts were biased by these research topics, which is part of the reason why generalization is impeded in this case. So as outlook, I mean, larger data sets, more data can provide answers to the question whether language transfer is to be found in the ACL or whether or not this is a corpus where NLI is just not successful. So thank you for listening.
Thank you very much. Time for questions. One question.
As the editor of the Computational Linguistics Journal, does that include the journal, your text for the ACL? That is heavily edited. So, you know, the native language of the author has been, you know, washed out by a large group of editors.
Well, no, we just use the network corpus. Yeah.
Right. So, but that includes only the conferences.
I think it includes everything. It goes quite far back in time, this corpus. So we get dates from the 90s as well. So I can't really answer your question as to where exactly they're coming from, but they're basically texts that have been found directly in the network corpus.
If I can add, why don't you think of just adding the research topic as a factor in your model, and then, you know, just sort of factor out that? Confound. It's a confound you have in your model.
Excuse me, can you?
It's a confound you have in your model. You can explicitly model, and then maybe.
And maybe you leave it out. Yeah, that's an interesting point. Yeah.
Okay. Second question. Okay.
Thank you, very interesting. But I was wondering whether you also includes in the set of features you are planning, because I understood formal features. So because the example you started with was a kind of ungrammatical syntactic construction, and I'm sure it will appear in the papers as well, for ACL at least. So I was wondering whether you already had a look at it, or whether you are planning to work on also on the underlying syntactic structure of the text.
This is a type of feature, the deeper linguistic features that has research has been done on this before in other work. For this specific task, we deliberately did not use deeper syntactic features. We kept it quite simple, but yes, this is definitely a possibility, and definitely a possibility for future work. Yeah.
Okay.
Good morning. I was wondering if you find some difficulties to understand if a mistake, an error, was a transfer error or another type of error, for example, a typo or something like that, and how did you solve this?
Okay, we made no distinction. If there's an error in say in a token and a spelling error, and we assume that just by simple statistics, if it occurs frequent enough by authors of the same native language, then we just conclude that this is a type of language transfer. But we don't actually go into those features and say that. I mean, as a linguistically informed sort of human looking at the features, no, we didn't say, okay, this can't be a topic of language transfer, because we just conclude just by simple statistics that if enough authors, it seems to something that pops up frequently by authors of the same native language, then we just say that that's language transfer.
Okay, unfortunately we have no more time, so therefore thank you very much. And the next presentation is by Giuseppe Attardi, Laura Gorrieri, Alessio Miaschi, and Ruggero Petrolito, Deep Learning for Social Sensing from Tweets. Thank you.
Good morning, I'm Laura Gorrieri. I will speak in Italian, but as you would see, the slides are in English, so it's easy also to see what we have done. Dunque, mi chiamo Laura Gorrieri e ho lavorato con il professor Attardi e due miei colleghi dell'Università di Pisa, che sono Alessio Miaschi e Ruggero Petrolito. Vi spiegherò brevemente che cosa abbiamo fatto. Partiamo quindi da un'introduzione. Lo scopo del nostro lavoro è stato quello di monitorare i social media al fine di riuscire a distinguere i tweet che riguardano un disastro naturale da quelli invece di argomento generico. Quindi nella pratica il nostro approccio si è basato sull'uso di word embedding discriminativi, che sono piuttosto efficaci per rappresentare aspetti contrastivi come la polarità e quindi l'appartenenza di un tweet ad una categoria o ad un'altra. Dunque il nostro lavoro è quindi un esperimento per l'identificazione dell'appartenenza di un tweet a due poli, che sono il polo dei tweet che riguardano disastri naturali e quello invece dei tweet di argomento generico. Diamo un breve sguardo ai word embedding. Dunque quelli tradizionali sono creati da una collezione non annotata di documenti e sono utili nel caso di ricerca di similarità sintattica o semantica. Quando invece lo studio si focalizza su qualcosa tipo la polarità, i word embedding tradizionali incontrano il limite che parole come gli antonimi finiscono vicine, mentre avremmo bisogno che fossero più distanti. Quindi per questo sono molto utili i word embedding discriminativi, che possono restituire la distanza che stiamo cercando tra parole che hanno appunto significato opposto e appartengono uno all'altro polo. I word embedding discriminativi che abbiamo utilizzato sono stati creati grazie a DeepNL, che è una libreria che usa un'architettura deep learning, e mette a disposizione un algoritmo e ha bisogno di un corpus di partenza comunque già annotato col valore discriminativo del tweet, quindi appartenenza a un polo oppure ad un altro, e crea gli embedding sia per gli n-grammi che per gli unigrammi allo stesso tempo. Il corpus che abbiamo utilizzato è quindi un corpus di tweet italiani che ha avuto ovviamente bisogno di essere focalizzato su disastri naturali, e quindi ci siamo affidati al corpus social sensing, che consiste in 5.642 tweet che sono stati annotati manualmente. Per bilanciarlo abbiamo aggiunto una raccolta di 23.500 tweet italiani su argomenti generici più disparati. Il corpus che si è creato in questo modo è stato poi diviso in un training set di 23.850 tweet, un development set di 2.649 e un test set di 2.650 tweet. E ora vediamo appunto cosa abbiamo usato a livello di classificatore di strumenti. Come classificatore ci siamo inizialmente affidati a un classificatore SVM di tipo binario, che utilizza come embedding per creare gli embedding in testi di Wikipedia in italiano. Successivamente abbiamo adattato degli strumenti tipici della sentiment analysis, che sono il gazzettino e il lexicon, che abbiamo creato di 292 parole che sono relative a disastri naturali, ad esempio terremoto, oppure anche parole simili, diciamo semanticamente, come scossa, eccetera. E abbiamo incluso anche le parole che iniziano con un hashtag, perché comunque siamo all'interno di Twitter e quindi sono molto interessanti anche quelle. E poi abbiamo creato una lista di feature riprendendo quelle usate nel sistema che ha raggiunto il punteggio più alto al SEMEVAL del 2014 sul task della sentiment analysis. Vediamo un po' più nel dettaglio le feature, e dunque sono queste 10 feature. Partiamo da all caps, che conta le parole presenti tutte in maiuscolo nel tweet. Poi abbiamo emopost ed emoneg, che restituiscono la presenza rispettivamente di almeno un'emoticon positiva e almeno un'emoticon negativa. Elongated invece restituisce la presenza di una parola, diciamo, con la finale allungata. E poi abbiamo una parte di feature che invece si basa sul lexicon, quindi ad esempio il conto delle parole del tweet che sono presenti anche nel gazzettino, lo score della parola del tweet presente anche nel gazzettino con lo score minore, e lo score dell'ultima parola presente nel tweet e nel gazzettino, e la somma di tutti gli score delle parole presenti nel tweet e nel gazzettino. Poi vi è una feature per contare le parole negative e le negazioni, quindi sia la negazione classica tipo non che parole tipo nessuno, niente. E infine vi sono riportati word embeddings con n che va da 2 a 4. I risultati del nostro lavoro sono stati ottenuti inizialmente con un classificatore di tipo SVM che crea embedding generici dai testi appunto di Wikipedia Italia, e poi sono stati selezionati 100.000 termini più frequenti, e per questi sono stati creati dei word embedding con 64 pesi. Successivamente abbiamo utilizzato anche un classificatore a rete convoluzionale, e abbiamo sempre utilizzato quello messo a disposizione da DeepNL. I risultati li vediamo brevemente in questa tabella. Sono praticamente divisi sotto data, trovate se sono risultati relativi al development set o al test set. In system invece vediamo baseline, che significa con gli embedding generici, DE quelli discriminativi, e convolutional invece usando il classificatore convoluzionale. E possiamo notare che già col passaggio tra embedding generici e discriminativi c'è un certo miglioramento soprattutto della recall e dell'F-measure, ma è con il classificatore convoluzionale che c'è il miglioramento migliore nei nostri esperimenti. Concludo citando un lavoro, diciamo, simile, anche se in realtà Il nostro approccio è piuttosto particolare e lavori con questa stessa finalità su dataset simili, non siamo a conoscenza che vi siano, però vi è un lavoro diverso sempre sul dataset di social sensing e il focus però in questo caso era un confronto tra vari esperimenti di in-domain, out-domain e cross-event, sempre sui disastri naturali. Grazie mille per l'attenzione.
Grazie. Any questions? One or two questions? One.
I'm asking you something about the resources you used, because maybe you assume that you used two different corpora, the social sensing corpus and the other general corpus. So can you say more how they were built, whether you built them or you used they already existed? So I think it could be interesting for everybody in the audience to know that.
The social sensing corpus was already built, and you can find in our paper the link to that one. And for the other one, I see also. Okay. Okay, they was already there, both corpus. Okay.
Another questions?
I have also a question regarding how did you pass the word embeddings feature to the classifier, since you have since it's not token classification but you are classifying a tweet. How did you manage to pass all the feature the corresponding vectors to the classifier?
Well, I mean, it's the word embeddings are just a vector, so they are just input to the classifier. So the classifier takes a vector as input, and so 50 of these values are the weights of the embeddings, and then the others are the discrete features that she's shown before. No, just as they are. I mean, just the input to the classifier are 50 weights from the embeddings, and then 12 or whatever weights from the discrete features.
Very last.
Features is to understand I mean, which words, other words are more related to one or the other polarity, right? So in this sense, have you tried other non-word embedding measure methods in order to build vectors that are associated with disaster or not, like more frequency-based approach instead of word embeddings?
No, this experiment was just trying to see how well the word embeddings, and particularly, and then comparing the word embeddings with this sentiment-specific word embeddings, which are learned from starting from the generic ones by using a second stage of training on the corpus, and that was the aim of the experiment. So we didn't compare with other techniques.
Thank you.
Maybe if you can say a couple of words to, let's say, let us understand the significant improvement of the convolutional classifier. Why?
Yes, good point. I have the question myself. So it was so good, I mean, I couldn't believe it. So yeah, true. And so I did it. I mean, maybe I did some mistakes. We had some, but so I tried. I restarted the experiment from scratch. I cleaned up everything and started the process from scratch again, and I obtained exactly the same results. So the data, the code, and the data are online. So if anyone wants to try it, I mean, I'm welcome. If you see there was, so I'm saying that the effect is it's very surprising. But there is a talk later this afternoon or tomorrow, I think, by the Moschetti and others, which also makes very outstanding results in sentiment analysis of tweet using the same technique. So that's just yes.
Convolutional, Pepe. It's
a
based
convolutional
on
neural network. Yes.
It's a convolutional neural network.
Yes.
Okay. So it's a perceptron, or it's a multi-layer architecture?
It's a multi-layer architecture. Do we have a picture? I think you should.
Sorry.
Sorry. I missed it. Okay.
Now, the idea of convolutional kind of classifier is that they are very good at modeling non-linearity. So that's the explanation. You get linear representation that comes from the embeddings that is already non-linear. And then you model in the classifier in a non-linear topological space. So you get a very complex matrix.
Well, there are two reasons. Well, the nonlinearity comes from the deep layers. So the convolutional neural network, I think, is 5 layers. So that's where it is capable of dealing with the nonlinearities. Then the convolutional part is that allows to take into account the whole sentence, the whole tweet, the individual parts of the sentence, and that is what, and it combines them all together. So that's where, yes, it combines. Yes, this is the picture, right? So this is the architecture of the convolutional neural network. That's Colbert, yes. Yes, it's from his paper.
Okay, yes. If you agree, we must go on. Thank you very much. And the next presentation is by Maria Laura Pierucci. Le scritture brevi dello storytelling, analisi di case studies di successo. Thank you very much.
Buongiorno, mi chiamo Maria Laura Pierucci e sono dell'Università di Macerata e lavoro al progetto di scritture brevi, come si capisce penso bene dal titolo. Dunque, una tradizione ormai consolidata di studi semiotici, di linguistica cognitiva e di psicologia indica la mente umana come narrante. E Roland Barthes nel 69 già diceva: il racconto è presente in tutti i tempi, in tutti i luoghi, in tutte le società. Il racconto comincia con la storia stessa dell'umanità, non esiste, non è mai esistito in alcun luogo un popolo senza racconti. Il racconto è come la vita. La riflessione sulle strutture della narratività, iniziata da Prop e dai formalisti russi negli anni 20 del Novecento, venne ripresa nella seconda metà del secolo scorso da strutturalisti come Barthes, appunto, Todorov e Genet, fra gli altri, che diedero il loro contributo all'elaborazione di una teoria narrativa a partire proprio dal presupposto che il raccontare e il raccontarsi siano fenomeni costanti nella storia dell'uomo, comportamenti all'essere umano connaturati, diciamo. Quando entra in gioco quindi lo storytelling e le scritture brevi, quando questa interazione? È con l'era digitale che lo storytelling si lega nella prassi al marketing non convenzionale, così viene definito, in una complementarietà disciplinare che contraddistingue sempre di più questo tipo di studi. Internet e la rete infatti si sono subito dimostrati strumenti di straordinaria efficacia per coinvolgere il consumatore in una comunicazione che fosse interattiva e personalizzata. Contributi di recente formalizzazione evidenziano la portata innovativa dello storytelling, soprattutto nella declinazione che individua in Internet l'infrastruttura portante e nelle virtual communities i driver essenziali per potenziare il contributo della dinamica narrativa al consolidamento e allo sviluppo delle relazioni sociali ed emozionali finalizzate alla brand loyalty. E questo lo trovate in Russo Spena con l'Urciomelia del 2003. I case studies che vi presento si contraddistinguono proprio per l'impegno di strategie di comunicazione che fanno leva sullo storytelling e su un impiego efficace delle sue scritture brevi e che così facendo potenziano il proprio brand. La prospettiva scientifica con la quale utilizziamo l'etichetta scritture brevi è quella definita da Chiusaroli a partire dal 2011 e soprattutto nel 2012 al 2014, che la propone come una categoria concettuale e metalinguistica per la classificazione di forme grafiche come abbreviazioni, sinonimi, acronimi, segni, icone, indici e simboli, elementi figurativi, espressioni testuali e codici visivi per i quali risulti dirimente il principio della brevità connesso ovviamente al criterio dell'economia. In particolare sono comprese nella categoria scritture brevi tutte le manifestazioni grafiche che nella dimensione sintagmatica si sottraggono al principio della linearità del significante, alterano le regole morfotattiche convenzionali della lingua scritta e intervengono nella costruzione del messaggio nei termini di riduzione, contenimento, sintesi, indotti dai supporti e dai contesti. La categoria applicazione sia nella sincronia che nella diacronia linguistica, nei sistemi standard e non standard, negli ambiti generali e specialistici. L'applicazione di questa etichetta si intende quindi sia nel senso stretto che vi ho appena specificato, ma anche come macro contenitore, laboratorio e osservatorio scientifico dei fenomeni della lingua del web, in considerazione del fatto che le campagne di strategia del brand esaminate sono state pensate per l'ecosistema digitale, nel senso di community di soggetti che interagiscono e si scambiano informazioni, e così facendo accrescendo conoscenze e contatti con lo scopo di migliorare la loro esistenza e soddisfare le proprie necessità. Ci sono quindi delle premesse teoriche di linguistica pragmatica, di pragmatica della comunicazione, fino ad estendere i propri confini scientifici a sottolineare come la narrazione del brand si costruisca attraverso il dialogo fra gli interlocutori, intercettati e coinvolti grazie a precise strategie di engagement nel contesto digitale. Quella social infatti è una dimensione in cui, dopo una fase fondamentale di listening del proprio target, lo storytelling viene ideato e realizzato per poi essere alimentato di scrittura e riscrittura. Anche quando si tratti di visual storytelling, la forma scrittoria che è creata e formulata dal copywriter mantiene la sua funzione di strumento di condensazione e formalizzazione del messaggio. Condensazione però non vuol dire necessariamente abbreviazione, si tratta di forme brevi di scrittura nelle quali la brevità non inficia i livelli di informatività. A volte, come nel primo caso di studio che presentiamo, può anzi essere forma e sostanza allo stesso tempo, o come trovate nel blog di Scritture Brevi, il mezzo e il fine. Prendiamo in esame la campagna di comunicazione promossa nel 2014 dalla Visa, la multinazionale finanziaria strutturata, Visa, la multinazionale finanziaria. La campagna di comunicazione è stata strutturata mediante visual storytelling. Il claim è "Let's go do something, going 6". Cosa significa questo? Significa su tutti i canali social, Facebook, Instagram, Twitter, YouTube, Vine, Google+, l'hashtag Going6 indica il numero 6 in secondi la durata dei teaser pubblicitari. In 6 è la quantità di foto per ciascun album, 6 le parole per ciascun post. Quindi 6 è la misura esatta in cui veicolare il proprio messaggio. La brevità diventa un esercizio della lingua anche nel web. Un tweet ha la lunghezza massima di 140 caratteri. La cosiddetta generazione millennium ha imparato a caricare su Vine filmati di 6 secondi. È di 8 parole la lunghezza media dei commenti in lingua inglese postata dai consumatori e quindi naturalmente da chi ha contribuito a questa campagna di comunicazione. Tornando a Going6, contesti che siano headline abbinati a video o foto, come ad esempio "Music under the moon sounds sweeter", "To be in or not to be in", parafrasando evidentemente Shakespeare, "Vacations are better with best friends", tutte stories in 6, tutte microstorie in 6 parole. La sfida a rispettare il limite di 6, quindi che fossero secondi, foto o parole, ha fatto guadagnare all'azienda 330 milioni di earn impressions, quindi contatti spontanei generati dal passaparola in un anno, con 36.838 interazioni. Visa è diventata la community con maggior engagement nel settore dei servizi finanziari ed è risultata seconda in assoluto nella più generale categoria lifestyle. Un altro caso di studio. Nati per proteggere è invece il claim dello storytelling promosso da AXA Assicurazioni sia nel 2014 che nel 2015. Raccontaci la tua storia di protezione, è stata la call to action. Hanno risposto in 351. Migliaia le visualizzazioni e primo premio al Corporate Storytelling Forum di Milano che si è svolto ad ottobre, lo scorso ottobre, quindi poco più di un mese fa. Gli elementi dello storytelling sono chiari. Il messaggio, naturalmente, è il tema principale attorno al quale si costruisce la storia. Il conflitto, che è la forza trainante di una buona storia, in ogni buona storia ce n'è uno. I personaggi, ciascuno ha un ruolo ben definito e in questi personaggi il destinatario si può immedesimare, e quindi la linea narrativa, il plot, che può avere un andamento differente a seconda che il racconto si ascriva ad un genere come quello tragico oppure ad un altro come nel caso di una storia d'amore. Digital storytelling, il racconto si struttura per immagini o filmati, ma la brevità rimane un elemento fondamentale che viene scandito dal pacing, cioè dall'uso del ritmo, della musica, della voce. Case studies di visual storytelling, ve lo faccio vedere rapidamente, se poi c'è tempo mandiamo anche il video perché dura soltanto un minuto. È quello che ha ottenuto oltre 500.000 di visualizzazioni su YouTube, realizzato dalla Ogilvy Matters per la catena alberghiera Shangri-La. Vi dicevo, 1 minuto di filmato completamente decontestualizzato rispetto al brand che lo ha commissionato, in cui i passaggi della narrazione sono sottolineati solo dalla colonna sonora e nel quale la headline, un esempio di scritture brevi in 54 caratteri, compare in chiusura anziché in esergo. To embrace a stranger as one's own. It's in our nature. In termini di pragmatica linguistica, il focus della struttura informativa è dislocato a sinistra, una forma marcata dal punto di vista dell'ordine delle parole, la cui efficacia è massimizzata dalla concisione. Di matrice culturale, infine, il progetto di branding attraverso storytelling promosso nel 2015, la scorsa estate, dal Macerata Opera Festival, in collaborazione proprio con il blog di Francesca Chiusaroli e Fabio Massimo Zanzotto, scritturebrevi.it. L'ente lirico marchigiano ha impiegato le tecniche di narrazione in ambito social, specificamente sulla piattaforma da 140 caratteri, raccontando le opere in cartellone, Rigoletto, Cavalleria rusticana e Pagliacci, Bohème, con brani scelti dai libretti, abbinati a foto dal vivo delle prime, durante il loro svolgimento presso l'Arena Sferistereo di Macerata. Uno storytelling lanciato con hashtag breve NutrimiLive, che è una forma contratta di 2 hashtag, quello ufficiale della stagione lirica Nutrimilanima e di live, inteso come spettacolo dal vivo. È stato quindi proposto sotto forma di live tweeting, che ha creato in seno alla comunità di scritture brevi 3 metatesti poi cristallizzati grazie allo strumento dello Storyfy. Insieme agli hashtag Rigoletto, Cavalleria rusticana e Bohème, NutrimiLive ha totalizzato 924 tweet, fonte Topsy, in corrispondenza delle 3 serate di live tweeting. Abbiamo così portato l'opera lirica sui social con un racconto fatto di immagini e di scritture brevi. In conclusione, in questo lavoro abbiamo analizzato molto rapidamente, mi rendo conto, alcuni case studies di storytelling e le loro scritture brevi, che siano claim, headline o hashtag, attraverso i quali quei racconti sono stati pensati e diffusi nel web per essere quindi intercettati nel mare magnum dei contenuti digitali. Abbiamo visto come lo strumento principe del marketing narrativo trovi la sua espressione in una coniugazione che deve essere sapiente di testo breve ed immagini, riuscendo così a tradursi in uno strumento efficace di branding per aziende, ma anche per enti culturali. Le regole da rispettare sono le stesse oggi come nel passato più remoto. Il racconto parla dell'uomo all'uomo e in virtù del fatto che i mercati sono conversazioni, vive una nuova stagione di successo grazie all'ecosistema digitale. Grazie.
Thank you very much.
Ora, se è possibile, se posso rubare un minuto, farei vedere il video, però chiedo se può essere interessante. Magari
first of all, are there any questions? And then
yes, please.
One question.
Una riflessione, una
Sì.
domanda, non sto bene. Qui si parla di tweet, si parla di digitale, però mi ha fatto venire in mente la famosa frase di Alexander Pope.
Sì.
Brevity is the soul of wit.
Yeah, it
Qui
is actually.
possiamo dire brevity is the soul of tweet.
Too.
Ma allora la
Yes.
domanda è, mi sono resa conto che questa frase di Pope è di 6 parole. E quindi
non la posso più
avete
aggiungere,
cioè,
purtroppo.
il collegamento che cui pensavo io, che c'è chiaramente un collegamento fra la brevità
Sì.
e il contenuto più emotivo del
Sì.
linguaggio, perché lui parlava di umorismo, di wit,
Certo.
e quindi la domanda è, c'è un motivo per cui sono 6? È solo perché è così molto corto? Potrebbe essere 5, potrebbe essere 7? Perché deve essere così corto?
Viaggiando il supporto detta un po' le regole. Il digitale impone la brevità come vero e proprio esercizio di lingua, che è innanzitutto un esercizio mentale, evidentemente, quindi wit, forse anche in questo senso. No, non credo ci fosse alla base una ragione perché 6. Con scritture brevi lo facciamo anche in 3, per esempio. Tweet di 3 parole che sì, veicolano emozioni sicuramente e anche significato compiuto, senso compiuto. Sì, certo. È comunque molto conciso, sì, sì. Il fatto che questa in particolare fosse una campagna promossa a livello planetario e quindi utilizzando l'inglese può aver condizionato la scelta, questo sì. Certo, è sufficientemente corto da poter essere veicolato su tutti i canali social, ma anche sufficientemente lungo da poter lasciare un pochino più di fantasia, no? all'utente finale. Grazie. Sì.
C'è il famoso romanzo di Hemingway in 6 parole, e quindi c'è la tradizione delle 6 parole, è ricca. Quelli di 3 parole non mancano di ritmo, comunque possiamo vederli magari anche. Prego. Un'altra domanda?
Sì.
Non vedo. Scusate.
Chiaramente qui sta parlando di un storytelling multimediale.
Mi scusi, non la sento.
Chiaramente sta parlando qui di uno storytelling multimediale.
Sì.
Perché io mi chiedevo se, come suggerimento che mi interesserebbe sapere,
sì.
Se fosse possibile fare un paragone con un altro tipo di multimedialità non digitale, che era quella dell'uso delle parole e di piccole frasi nei film muti.
Sì.
Perché c'è una brevità sicuramente e comunque alterano in qualche modo il ritmo della narrazione a tutti e due i livelli, sia diciamo linguistico sia...
Sì, di fatto, come dicevo prima, il supporto condiziona, no? In questo senso, dicevo, scritture brevi si occupa anche di espressioni nella diacronia, di espressioni linguistiche nella diacronia, perché da sempre il supporto condiziona. Evidentemente nel momento in cui il cinema muto, no, ancora non si avvale del supporto del sonoro, necessariamente il messaggio verrà strutturato affinché possa essere recepito e decodificato in maniera utile al target quanto più ampio possibile.
Sì, appunto, ma l'idea sarebbe, cioè, come la vedo io, è che spesso nel cinema muto si adattavano romanzi o testi comunque precedenti, per cui in qualche modo cambia anche lì, diciamo, la natura della narratività, che diventa più multimediale. Non so come spiegarmi, si capisce quello che intendo.
Sì, non sono un'esperta di cinema muto, immagino che possa dirsi di sì. Prego.
Abbiamo avuto contributi comunque anche di esperti di sottotitolaggio e cinema muto. Comunque ora mi impongono giustamente di concludere e possiamo continuare anche la conversazione fuori. The last presentation for this session is Alessandro Mazzei, Generare, messaggi persuasivi per una dieta salutare. Thank you very much.
Ok. Per essere particolarmente intelligente dovevo essere molto breve, no? Anche perché la Chair da lontano mi sta guardando male da un'ora. Ok, allora parlerò in italiano per cercare anche di essere un po' più breve. Parlo di generazione del linguaggio, non ci sono tantissimi lavori, piccolo riassunto su un'introduzione su che cos'è Natural Language Generation. Costruire fondamentalmente dei testi che rispettino certi goal. Chiaramente questo task può essere eseguito in tantissime maniere. Fortunatamente, diciamo che nella comunità di NLP, NLG sta anche in NLP, nonostante P sia processing, comunque questa è l'architettura standard che si è diffusa all'interno della comunità NLG. Questa architettura ha due vantaggi fondamentali. Uno, quello di dividere i task fondamentali dell'NLG in 8 subtask fondamentali che vedete sul fondo della slide, e sono content selection, determinare quali messaggi, quali nuclei di messaggio sono fondamentali da comunicare, discourse planning, come strutturare, per esempio in quale ordine dare questi nuclei di messaggio. Poi abbiamo il sentence planning, quali parole scegliere per comunicare questi messaggi e come coordinare tra di loro le frasi. Questo è lexicalization, aggregation, referring expression riguardano questo. Infine la parte di linguistic realization, cioè in quale ordine mettere le parole, introdurre le parole funzionali che di per sé non hanno significato, quindi preposizioni, articoli, inflections, flettere le parole. Quindi diciamo che il vantaggio di questa architettura, che è un'architettura proposta da Reiter ormai nel 2000, ha il vantaggio sia di identificare questi subtask, sia di far capire quali sono le due basi di conoscenza fondamentali, quelle sul dominio e quelle sul linguaggio, come intervengono all'interno di questi 8 subtask. Storicamente l'NLG è sempre stato visto un po' con sospetto da chi si occupa di analisi. Perché? Perché è tutto facile. Chi fa analisi, chi fa syntactic parsing sa che il problema grosso è l'ambiguità, ma se tu stai generando non hai ambiguità, tu sai cosa vuoi dire. Allora perché per tutta questa gente per tutto questo tempo? Un po' questo è la domanda che viene da come viene dal parsing. Beh, i motivi ci sono, non è la scienza, il problema grosso della generazione non è tanto l'ambiguità, ma il problema delle scelte, che una scelta fatta male all'inizio può determinare poi dopo un messaggio scritto male. Quindi c'è sempre stato diciamo la contesa tra un NLG vero e quello che si chiamano i template stringa. Questa è una frase di Reiter che cerca un po' di riassumere, dice fondamentalmente i template non sono altro che delle stringhe in cui non c'è la vera strutturazione a livelli tipica della linguistica. È vero che però anche i template hanno dei grossi vantaggi, si fanno molto velocemente, non hai bisogno di tanta informazione linguistica. Il printf standard di chi fa programmazione è Natural Language Generation con template in qualche maniera, va bene? Ci sono diversi sistemi ibridi, quello che vado a finire, diciamo, che vi dettaglierò nella parte finale di questa presentazione, è un sistema ibrido che usa parzialmente tecniche di NLG, quindi parzialmente tecniche di linguistica, di livelli di linguistica, e altre parti che invece vengono dai template. C'è una tradizione, insomma, nel mischiare template e NLG vera e propria. Questa è l'outline. Il progetto di cui parlerà si chiama Madiman e riguarda il cibo, in qualche maniera, il linguaggio del cibo. Vi parlerò di come si fa il document planning all'interno di questa architettura per generare dei messaggi che riguardano la dieta. Qualche cosina vi dirò sul sentence planning, in particolare sull'aggregazione, ovvero il problema grosso della dieta è che tu devi uno dei tanti problemi delle diete è che tu devi ragionare su diversi macronutrienti, che sono i lipidi, che sono le proteine, che sono i carboidrati. Di per sé sono 3 informazioni su 3 canali diverse. Una dei task che vi ho detto, dei subtask di cui vi ho parlato nell'NLG, si chiama aggregation, cioè mettere insieme frasi che riguardano domini semantici diversi, ed è questo quello che il topic della ricerca, uno dei topic della ricerca di questo progetto. Infine, fare una breve esplorazione nel mondo della persuasione. Ci sono tantissime teorie che riguardano la persuasione. Chiaramente dire una cosa usando delle parole può cambiare totalmente il valore persuasivo di quella frase. Ce ne sono tante, ve ne parlerò di qualcuna di cui io ho preso spunto nel design dei miei messaggi. Quindi questa è l'architettura, a virtual dietitian that is able to recover the nutritional information directly from a specific recipe, to reason over recipes and diets with flexibility, per permettere delle forme di disobbedienza. Il punto fondamentale è che tutte le app che voi scaricate, dai vari market che vi dicono, che cercano di farvi seguire una dieta, hanno un problema fondamentale, che è quello della poca flessibilità. Non mangiare questo piatto, ma se tu poi decidi di mangiarlo, niente, è finito, game over. Invece no, l'idea qua è diversa. Voglio permettere delle forme di disobbedienza, ma cerco di persuadere l'utente a farne il meno possibile. Tutti noi mangiamo le patatine fritte, va bene? È chiaro che dal punto di vista dietetico le patatine fritte sono un'eccezione. L'importante è ricordarsi di aver fatto quell'eccezione. Ci sono degli studi che dimostrano che se noi facciamo delle eccezioni, ci dimentichiamo sempre poi di compensare. Quello è il problema fondamentale. Dici, ma perché non dimagrisco? Beh, se vai tutte le domeniche a cena da mamma, vedrai che se non fai lunedì un po' di dieta, ingrassi, non c'è niente da fare. Questo è un problema grosso e i sistemi mobili possono aiutarci a tenere a mente di queste disobbedienze. Questa è l'architettura dell'NLG che sto usando. L'input del mio sistema di NLG è un ragionatore automatico basato su Simple Temporal Problems. Sto lavorando con i planning, con chi fa planning, quindi non sono solo io che mi occupo, che lavoro su questo progetto. Uno dei punti fondamentali è che da questo ragionamento deve uscire sia una forma simbolica che verrà usata in generazione, sia una forma numerica che riguarda poi i valori numerici per poter poi dare anche dei suggerimenti su che piatti mangiare nei giorni successivi. Oggi mangi patatine, domani mangi un po' di insalata. Vabbè, faccio esempi semplici, va bene? Però giusto per dare un'idea. In questo caso, ad esempio, il piatto risulta essere scarso di carboidrati, di essere molto ricco di proteine e di essere ok per quanto riguarda i lipidi. Okay? In questo caso il suggerimento che verrà dato per il pasto successivo equivalente sarà quello di mangiare poi del riso al pomodoro. Va bene? Come vi dicevo, un punto fondamentale, avete già fame a quest'ora, eh? Ok, un punto fondamentale appunto che vi dicevo è come passare l'aggregation, questa parte in verde, che ci dice come passare da una serie di messaggi che sono singoli ad una forma strutturata. La fluency, cioè il fatto di dare dei messaggi singoli, non fa che far percepire il sistema come un sistema artificiale. Sappiamo che dobbiamo trovare un compromesso. Gli esseri umani lo riescono a fare bene. Chiaramente è una sfida dell'NLG quello di riuscire a farlo ugualmente bene. L'output del ragionatore può essere di diversi tipi. Il piatto può essere tremendo, ok? Cioè proprio stai mangiando la cosa più schifosa del mondo e non dovresti mai mangiarla, oppure può essere incompatibile, debole, cioè nel senso in quel momento non puoi mangiarlo. Se ieri ho mangiato patatine, oggi non puoi mangiare patatine di nuovo, va bene? Però puoi mangiarlo la settimana prossima, quindi abbiamo un'incompatibilità debole in quel caso. Oppure varie forme di compatibilità più o meno perfetta, dal debole al perfetto. Va bene, quindi abbiamo I1, I2, che vuol dire incompatibile per sempre, incompatibile debole, compatibilità forte e compatibilità perfetta. Questo mi serve poi per fare il document planning. Come verrà fatto il messaggio? Seguirà uno schema di document planning, quindi uno schema generale che ti do la risposta generale, puoi mangiarlo o non puoi mangiarlo, ti spiego il perché non puoi mangiarlo, non puoi mangiare oggi le patatine perché ieri hai mangiato un hamburger, va bene? E poi ti dico, forse sarebbe meglio se prendi dei fagioli. Quindi lo schema principale, diciamo, del rhetorical message è questo: una risposta più una spiegazione più un suggerimento fa il messaggio finale. Questi sono i messaggi sul singolo macronutriente, quindi stiamo supponendo ora di creare i messaggi singoli, quindi solo sulle proteine, sui carboidrati, e questi sono, diciamo, degli schemi che abbiamo costruito partendo da alcuni elementi delle teorie persuasive. Quindi questo piatto non va fatto bene, contiene davvero pochissime proteine, vuol dire che non lo puoi prendere mai. Mentre invece questo piatto va bene, è solo un po' scarso di proteine, vuol dire che c'è una compatibilità non perfetta, ma comunque il piatto va bene. Va bene. Il punto fondamentale dal punto di vista dell'NLG è come aggregare tra di loro queste frasi. Quindi dal punto di vista della ricerca, la parte veramente interessante era quella verde, va bene? Quella che vi sto facendo vedere ora. Nel caso ci siano delle incompatibilità, niente, l'aggregazione è molto semplice, devi dare il messaggio su quello che rende incompatibile. I carboidrati sono veramente troppi, non puoi prenderlo, va bene? Mentre invece nel caso in cui siano tutti compatibili in maniere diverse, per esempio in questo caso hai una compatibilità perfetta, una compatibilità media, una compatibilità debole, beh, allora devi costruire una struttura, vedete che qua c'è un ma, poi c'è un punto e poi c'è di nuovo un ma, va bene? Quindi questi tipi di schemi servono per l'aggregation. Stiamo lavorando su questo, cioè per creare per ognuno di questi 10 casi poi un sistema di aggregazione. Quali sono le teorie persuasive che ci hanno, tra virgolette, dico ispirate? Perché? Perché non sono teorie sempre formalizzate. Alcune di queste teorie vengono fondamentalmente dal design industriale, cioè quello Captology, Computer as Persuasive Technology, un laboratorio di Stanford. Ok? Quindi a Stanford trovate il signor Fogg, che è uno psicologo che fa per metà il professore e per metà il consulente per le aziende, che vi dirà che ci sono tutta una serie di tecniche che vi permettono di costruire messaggi persuasivi. Una di queste è, per esempio, il fatto che ci sono dei principi di design dei tuoi messaggi. Beh, fondamentalmente, per esempio, uno dei punti fondamentali, quello che qua c'è scritto Kairos, è che il messaggio deve essere dato nel momento in cui serve, no? C'è un articolo storico che è quello di Reiter, dello 03, che si chiama Stop, in cui lui aveva provato a scrivere delle lettere persuasive con NLG per far smettere di fumare, no? Ecco, lui dimostra che è un fallimento totale. C'è l'articolo di Artificial Intelligence che è molto interessante, perché cosa possiamo imparare da un fallimento totale? Lui dice uno dei problemi grossi è che tu spedivi una volta a settimana questa mail, mentre invece è nel momento in cui serve, in cui sto scegliendo il piatto, che io devo dare il messaggio persuasivo. Quindi Cairo, quest'idea diciamo di Fogg dello 02 è quello di dare il messaggio nel momento giusto, e noi lo facciamo perché il mobile ti permette di farlo, diciamo, mentre qualche tempo fa non si riusciva. Ci sono varie cose che potrei dire. Vabbè, comunque, Cartology, diciamo, non ha un approccio molto formale, riguarda molto appunto il design industriale. L'altra teoria che, insomma, ci ha ispirato è quella di Cialdini, che è un altro abbastanza famoso, un psicologo americano abbastanza famoso, che dice che, per esempio, da 6 principi base che riguardano la persuasione, e noi abbiamo usato alcuni di questi. Per esempio, si sa che le persone sono persuase se il messaggio viene da degli esperti. È chiaro che l'idea del dietista virtuale che vive nel tuo smartphone ha un'autorità diversa dall'amico che, diciamo, ti dice prendilo o non prendilo, perché si basa su algoritmi, diciamo, di dietistica. E così noi stiamo collaborando con dei dietisti delle Molinette di Torino per fare questa roba, insomma, quindi c'è veramente dell'informazione, voglio dire, medica qua dentro, non è solo. Poi quelle sottolineate sono le altri principi che noi abbiamo usati, per esempio consistency, people do what they said. Beh, sei tu che hai scelto la tua dieta, io ti sto solo ricordando col messaggio quello che tu hai scelto, quindi questi sono altri principi. Le altre cose altre teorie fondamentali che entrano nel design del messaggio sono il tailoring, cioè il fatto che un messaggio per un adolescente deve essere diverso da un messaggio per un quarantenne, che deve essere diverso da un messaggio del settantenne. Di la verità, in questo momento ancora nel sistema non c'è il tailoring, ma è chiaro che il tailoring è fondamentale. Pensate a dare un messaggio ad un adolescente e invece darlo ad una persona diciamo, di un'altra età. Devi usare uno slang completamente diverso. Sono messaggi brevi, sono scritture brevi, quindi devono comunque rientrare all'interno di quelle teorie che abbiamo visto anche prima. L'ultima cosa che voglio dire, per esempio, è l'emoticons. Alcuni studi hanno dimostrato che le emoticons devono essere usati solo quando dai dei messaggi positivi. Se tu stai dicendo che questo piatto non lo devi prendere, non devi usare le emoticons, perché in quel caso perdiresti di credibilità, no? Quindi, per creare il clima amichevole, bravo, questo piatto è perfetto, una bella faccina va bene, ma se tu devi dire che il piatto invece non va bene, è meglio non usare le emoticons. No, vabbè, questo forse è un po'... Lo so che tutte queste possono sembrare delle considerazioni di buon senso, ma è questo che parte del lavoro, insomma, dei psicologi è quello di fare emergere in distillati quello che noi chiamiamo buon senso. Ci sono altre regole. L'ultima cosa che voglio, appunto, qua a Trento il gruppo del professor Stock ha lavorato sulla persuasione e ancora ci lavora. L'approccio è meno design, ma è più artificial intelligence. C'è un agente in un contesto BDI che deve convincere un altro agente umano oppure artificiale a seguire un certo comportamento. Chiaramente è più vicino alla ricerca rispetto ad un'implementazione vera e propria come le teorie precedenti. Ci sono tante cose da dire su questo, ma non ho il tempo. L'unica cosa, come proviamo a testare il nostro sistema? Per ora non abbiamo ancora una valutazione. Una prima valutazione che ci hanno suggerito di fare in certi articoli, in alcuni articoli che abbiamo mandato sul ragionamento automatico, è quello di usare una simulazione. Questo chiaramente permette di vedere se il ragionatore funziona. È più difficile capire se il messaggio è persuasivo. Certo, l'user modeling potrebbe in qualche maniera distinguere utenti che sono più persuadibili rispetto ad altri, ma non è così semplice, insomma. No? Cioè, questo molto probabilmente non è la tecnica giusta per vedere se il messaggio è veramente persuasivo, ma c'è bisogno di un control group, quindi di un tipico protocollo medico con un gruppo di controllo. L'altra cosa che stiamo provando a fare è implementare Simple NLG, che è un sistema standard per la realizzazione linguistica, per l'italiano. Quindi ora stiamo lavorando con un borsista per portare questo pezzo, diciamo, di NLG all'interno del mio sistema, e potrebbe essere di grosso aiuto per tutta la comunità che si occupa di NLG. Grazie per il tempo.
Grazie, thank you very much. One question.
Dunque, il formalismo che usi per rappresentare la conoscenza, quindi prima che entri nella tua pipeline di generation, quindi esatto, è una cosa che avete inventato, quello più la parte in basso numerica, è una cosa che
abbiamo parlato con questo dietista delle Molinette, diciamo, con cui ci siamo messi un po' d'accordo.
Sì, la mia domanda è se si basa su una delle varie teorie di rappresentazione della semantica o è una cosa che avete fatto specificamente per questo progetto?
Non è un formalismo logico standard, è semplicemente un formalismo simbolico che ci siamo un po' inventati sui 3 macronutrienti, che appunto sono lipidi, proteine e carboidrati, considerando il fatto che può essere sia ipocalorico che ipercalorico. Vedi che qua c'è scritto ipo e iper, no? Quindi mancanza oppure eccesso di un certo macronutriente.
Quindi questo non ha delle limitazioni nel caso volete applicare questa pipeline che per il resto è generica.
Sì,
ad altri domini, ad altri
assolutamente, ma quando fai data to text, come sai, non puoi, questa è quella che si chiama data analysis, non puoi uscire fuori da questo, cioè devi per forza trovare una rappresentazione. Per dire, in altri progetti in cui ho lavorato su NLG usavamo un first order logic, no? Però anche là poi la first order logic è un formalismo, ma poi tu dopo è il dominio quello che poi ti dice se il sistema è riutilizzabile oppure no. Questo è il punto fondamentale. Tu puoi usare hybrid logic, quello che vuoi, però poi dopo se il dominio non è modellato in una certa maniera non è riutilizzabile. Quindi è un po' quello il punto.
Bene, c'è poiché ci sono gli organizzatori tutti in piedi, quindi mi dispiace, ecco, concludere. Le domande possono essere fatte anche individualmente fuori dalla sessione. Thank you very much.
Good morning. This is the last session of this morning. We are half an hour late. So since everybody wants to have lunch at the perfect time, so what we can do is to have 2 papers now, then go and have lunch, and then after lunch. So anticipate a little bit the end of lunch and then continue with the following 2 papers. So I'll ask the speakers to be sharp, dead sharp, where dead means if you're not punctual, then you'll be dead. Okay, so first paper is by Elena Cabrio and Serena Villata, Inconsistency Detection in Bipolar Entailment Graphs. Elena, please.
Okay, so good morning to everyone. So I'm presenting this work done with my colleague Serena Villata on inconsistency detection in bipolar entailment graphs. So as most of you already know, textual entailment is a directional relation between 2 textual fragments, a text and an hypothesis. And there is an entailment relation if H can be inferred from T as interpreted by a typical language user. But actually, in some real world scenarios, such pairs cannot be considered as independent. Because, for instance, if we think about customer reviews, we want to have all the relation among the different claims of the different people, and then have an overview of what people think about a certain issue. So what we would need is more similar to an entailment graph, in which textual entailment pairs are also part of a graph, providing an overview of the entailment interaction. But the problem is that the combination of textual entailment into a unique graph may generate inconsistencies that are usually detected only after by human annotators. So what we want to do here is to understand how we could support annotators in detecting inconsistencies in textual entailment graph, in particular when there is a lot of data to be checked. So we propose in this work bipolar entailment graph that, differently from a previous definition of entailment graph from the Varilan group, here we have 2 kinds of edges, so the entailment and the contradiction, and we will use this structure to reason over the graph consistency. So we rely on abstract argumentation theory that has been proposed by Dung, and that is a reasonable framework to detect and solve inconsistency in the argumentation graphs. So here, nodes are called arguments, and in, I didn't say it, but in the argumentation theory, so arguments are claimed in a certain debate against or to support a competing argument, a competing issue. So edges are represented by a conflict relation, and several argumentation semantics are being proposed to compute consistent sets of arguments, given the conflicts among them. So in this work, more specifically, we propose the Baggings framework that translates a bipolar entailment graph into an argumentation graph. that allows us to use and to apply these argumentation semantics. So here is the Baggins framework. So as input, it receives a data set with all the pairs about a certain issue. As a first step, we apply a textual entailment engine to detect the relation of entailment and, let's say, contradiction among pairs of arguments. Then all these different arguments are put in a graph so that we can reason over it and apply these semantics from the argumentation theory. So we obtain a graph like this one, where certain arguments are accepted and the other ones are rejected. So since these semantics provides us by definition, only consistent sets of arguments, if we find an inconsistencies, it means that the textual entailment system made some mistakes. So it will be much easier for an annotator to understand where the problem has been took place. Okay, so just a few words on abstract argumentation theory. So arguments are represented as abstract nodes of a directed graph. So we have nodes are abstract arguments and edges are attack relations. And thanks to this attack relation, they can model the conflict among the different arguments. Using these admissibility semantics, they compute these arguments that are accepted. So basically, the arguments that survive to the conflict. So different acceptability semantics have been proposed that produce 0, 1, or several consistent sets of accepted arguments. From it, it derives that an admissible set of arguments is required to be internally coherent, so that should be conflict-free. And in Baggins, we use the admissibility-based semantics, according to which an argument is accepted if all the arguments attacking it are rejected, or it is rejected if there is at least one argument attacking it that has been accepted. Okay? And actually, so the set of accepted arguments are called extensions. And adding another argument to this extension may cause the set to be inconsistent. Okay, so let's, in order to be able to, let's say, map or to traduce the bipolar entailment graph into the argumentation framework, we have to define the entailment and the contradiction relation in this new context. So let's take a pair connected by an entailment relation. So we have the first text that says natural gas vehicles run on natural gas, so emit significant amounts of greenhouse gases into the atmospheres, albeit smaller amounts of the gasoline-fueled cars. To combat global warming, we should be focusing on our energies and investments solely on zero-emission electric vehicles. And then we have an hypothesis that says that on the surface, natural gas cars seems all right, but the topic becomes a bit different when they are competing against zero-emission alternatives, like electric cars. So this is a clear example of entailment, as it becomes clear that in general, a more specific text entails a more general hypothesis. So here, as I'm saying, to traduce the bipolar entailment graph into an argumentation framework, and in particular, the entailment relation, we have to model it as an attack between abstract arguments in an argumentation graph, because this is the only relation that is possible to use. So from our considerations, it derives that assuming that T entails H, then if there is a text fragment, T1, T prime, which contradicts H, then T prime contradicts also T. And if there is a text fragment, T2, which contradicts T, then T2 does not necessarily contradict also H. And from the argument's accepted viewpoint, we have that given that T entails H, every time argument H is rejected, argument T is rejected too. So in order to have T accepted, also H should have been accepted. We have to do the same kind of translation also for contradiction. So let's take another example in which this relation holds. So we have another text in a debate that says the natural gas is the cleanest transportation fuel available today. And if we want to immediately begin the process of significantly reducing greenhouse gas emissions, natural gas can help now. Other alternatives cannot be pursued as quickly. And the hypothesis is the same as before. So on the surface, natural gas cars seems all right, but the topic becomes a bit more different when they are competing against zero-emission alternatives. Okay, so in the, let's say, textual entailment framework, the contradiction has been defined by de Barneff as existing when two fragments cannot be true at the same time, and they talk about the same event. So here, actually, we have the text and the hypothesis conflict with each other, so in the bipolar argumentation framework. So it is not possible to have both in a coherent and consistent set of arguments. But differently from what proposed by Dung, in our case, there is not an attack, directed from an argument to another, but we actually have a cycle of attacks. Here, this is basically the core of our work, in which we show the translation procedure. So A is actually our T prime, C is the hypothesis, and B is T2. So what we do here is to introduce dummy arguments to be able to model the relations of entailment and contradiction in the same way as for the argumentation frameworks. So for instance, for the entailment relation, we only need one dummy argument from A and C. That allows us to say that actually both A and C have been accepted. Okay, and in the second one, in the contradiction, it's a bit different. We need two different dummy arguments to be able to actually accept one node and to discard the other, because this is the case of the contradiction. Okay, then dummy arguments are filtered when we give back to the annotators the set of accepted arguments. So here we give back A, C, corresponding to T prime and H, that are both true at the same time, while for the second case of contradiction, we only accept C, and we reject B. Okay, so we try to evaluate our framework on the Debatepedia dataset. That is a dataset that we built in 2002, taken from like a social network, let's say forum, in which people debate about certain topics. And we use it because actually it already provides us categorized arguments according if they are in favor or against a debated issue. So here we have 160 pairs as training set and 100 pairs as a test set, and they are balanced between entailment and contradiction. Actually, I must say that we have not evaluated yet, it's in the future work, how this really helps the annotators, how it speeds up the process. For now, we have evaluated how the textual entailment system behave on this dataset and how these mistakes produced by the textual entailment systems are distributed and are actually made the results of the entailment of the argumentation graph worst, because actually the application of the argumentation theory of the admissibility-based semantics cannot be wrong. So it's just a computation. But the problem comes when textual entailment system provides a mistake. Okay, so these are the results we obtained on the first step, so on textual entailment only, and we use the excitement open platform, and in particular the BUT systems gave us the best results, and then we use the edit distance ADA as a baseline. And then as a second step, as I said, we want to evaluate how much these mistakes are propagated in the argumentation graph. So in general, these are the results we obtain in this second step. But it's not a real evaluation on the annotators yet. So to conclude, so we propose the Baggings, that is a framework to translate a bipolar entailment graph into an argumentation graph that allows us to detect inconsistent sets of arguments if a wrong relation assignment by the textual entailment systems occur. So if no mistakes are produced by the textual entailment system, by definition, Baggings semantics return consistent argument set. And as for future work, as I said, we plan an evaluation with the annotators, and we plan to verify and ensure the transitivity of the bag of the bipolar entailment graphs. And there is a most important issue, is to try to ask the natural language processing community to contribute in the effort of building resources of interconnecting textual entailment pairs, because now this is becoming more and more frequent in real-world scenarios. So thanks.
Congratulations, Elena, you've been really on time. So we have time for one question.
people want to hurry up.
Don't be afraid. Go ahead. Okay, one question there.
I would like to ask you a similar question to the one I asked to Viviana. So you are working. You started working on the argumentation part, while Viviana started from the opinion mining. So do you see, even in terms of resources, which was your last point, any possible contribution of the opinion mining community to the argumentation community in terms of resources or in terms of solutions?
I think so. Actually, we are trying to do some kind of works also on Twitter on argumentation. So basically, we take these tweets and we try to, again, understand which are the polarities and which are the actually relations among them. So yes, I think that these two communities, then communities or two different tasks, can kind of try to interact as possible. Yes. So I think it's something to investigate, because in this case, we don't have a lot of resources. So when checking, the one that we produced are basically the only ones. So yes.
Okay, thank you. Second paper by Pierpaolo Basile, Annalina Caputo, and Giovanni Semeraro. Annalina Caputo is presenting. Entity linking for Italian tweets.
Good morning. This is a work about entity linking for Italian tweets. And I will set up the scene as first about entity linking task. That is the problem of finding and linking each entity mentioned in a text to a knowledge source. Like in this case where McDonald refer, to a person. But the task actually is quite hard, because usually entities are very ambiguous, like in this case. And even if we consider just persons, we may have many of them. And in this case, we need to resolve an ambiguity. So we need to perform a disambiguation between the entities in order to find the right one. However, when we talk about Twitter, things are even worse, because we have many problems due to the noisy, the poorly written text, and also the short text that usually provides a small context to perform the disambiguation task. But when we consider Italian, we have even more problems due to the lack of data sets for the training of mini systems that are, for example, supervised. So our first attempt to solve this kind of problem was to make available a data set for Italian tweets, or manually annotated tweets. And this is a very tough task, because it requires not only the recognition of a mention of an named entity in the text, but also you need to look up for each potential entity in a knowledge source, and also to disambiguate them. And as we have just seen, it's like in this case, it's quite hard to detect the proper mention, even for us as humans. So we were inspired by the micropost and named entity linking challenge that took place this year. And we randomly selected 1,000 tweets from the Twitter dataset, and we made this dataset available as a project on GitHub. For each proper noun that we detect in a tweet, we decided to which category it belongs. So we tagged this proper noun with a category, and then when there is a link to a DPpedia concept, we tagged also this noun with the proper link. Otherwise, we choose to link to tag that noun with the nil tag. From the annotation were excluded all the preceding articles and also other prefix or post modifier, but we decided to annotate also tags and mentions that are typical to Twitter when they refer to an identity, of course. These are the category that we exploited in our annotation. They are things, event, charter, location, organization, person, and product. I need to point out that even when an identity refers to nil, so it doesn't refer to a concept in Wikipedia, they still has to be annotated with the right category. This is an overview of some statistics about categories and the links in our dataset. The annotation has been performed by one annotator and resulted in 756 entity mentions. The most prominent category was the persons one, while for links, most of the links were made to the English Wikipedia. Another important part of these mentions were linked to nil, so to nothing at all, followed by just a few links to the Italian Wikipedia and only one link to Italian Wikipedia. We treated Italian Wikipedia and Italian Wikipedia separately because they are not there is a not complete overlap between these two resources. The annotation task resulted then in a TXT file with one row per each annotation, where we can find the Twitter ID followed by the start and the end character offset. Then we have the Wikipedia URI and then the category. So on this dataset, we performed the first evaluation with an adaptation of previously disambiguation algorithm. That is an adaptation of the LESC algorithm, which exploits also a distributional semantics model. In this case, we decided to index with Lucene all the possible surface forms that refer to the same concept, and then when we performed the recognition by taking the text of a tweet, we performed on this text the tokenization and the normalization, and we generated all the possible n-grams. Then we queried the Lucene index with these possible n-grams, and we obtained a candidate list of surface form. For each surface form, we get the list of all possible concepts, and then on this list we perform the disambiguation task. That actually consists in computing a semantic similarity in a distributional semantic space between the vector that represents the gloss of the concept and the vector that represents the context. In this case, we exploited as a context the whole tweet. Then we evaluated this system on our dataset, and we compared this system with other systems that were available for the Italian language. Specifically, we compared Babelfy with the TagMe, TextRazor, and DSM-Tel, that is our system. The first task was the entity recognition with and without an exact match, where in the non-exact match task, we allowed for a non-perfect overlap between the gold standard and the annotation produced by the system. So we can see that in this case, Babelfy achieved very low performance, but this is due to the fact that Babelfy was not conceived, was not tuned for the Twitter context. this is also an indication of how hard is the task of recognizing entities in the tweet in the context of Twitter. In the recognition task, our system achieved the best performance, that is around 0.5. But as we can see for the linking task, things went a little differently. Still, okay, the three system, TagMe, TextRazor, and YesMTel, got comparable results, but actually the best performance system was TextRazor. We compared also these results with the micropost results for the English task, and here we can see that the recognition task is harder, because we got lower results than for the English task, but in the linking we get better performance. In general, I'm speaking about all the system. And in this case, TagMe actually was the most performance system. So concluding, this is a work that actually is the first preliminary attempt to tackle the problem of entity linking for Italian tweet. We just tried to set up a data set and also to start, we start to compare some system on this kind of task. But actually, our goal is to extend this initial data set with more annotated tweets, also in order to provide some training data. And we are planning to propose a task for the next edition of Evalita, for which actually we kindly we welcome any collaborator for the organization. So thank you.
Thank you, Annalena, for being in time. We have time for 2 questions.
Okay. So the first is a suggestion. There is several papers by Blanco, Ottaviano, that show how to do entity linking on queries, search engine queries.
Mm-hmm.
And they do it using word embeddings, and they achieve outstanding results. So I was wondering whether you looked at the paper.
Yeah, I know.
And okay, and how this would, if you have considered using that approach. Second question is more technical, because you seem to be using a kind of unusual way, a search engine to do classification. So why don't you use a classifier instead? I mean, typical traditional classifier, and yeah, here.
Yeah.
And the center column appears to be doing basically what is a classifier task, because it produces a list of possible concepts. So that's a classifier.
Not actually.
Okay.
It produces a list of possible candidates. I mean, the retrieval task in this case is just to for recognizing entities. Then we pass to a disambiguation task in which we actually exploit word to vector, that is a kind of word embedding. I'm aware of the work of Blanco et al., Mage and et al. Yeah, and we are also working in that direction. I didn't give too many details because I want not to enter into many details, also for some time constraint. But yeah, okay, thank you. Other questions?
Another question?
Okay.
We have time for another question.
Maybe they are angry.
It's not ready yet.
Related to the proposal for a task at Evalita, is there any specific reason to limit the task to tweets and not to extend it to other, let's say, kind of social media, for instance?
Oh, yeah. Actually, we were more interested in Twitter because it's even more hard. It's harder to take this kind of context for the problems that I show you. So we just focus on this on this task, but we we can actually widen our view and consider also other sources of, for example, microblogging or posts in general. Yeah. In that case, it will be simpler, the disambiguation, because you have a bigger context. So maybe there are more mentions in the same text, and it's not so easy, but it's easier than this. Okay, thank you for your attention.
Okay, so we will continue with the next two papers after lunch. And I would like to ask you to be punctual and be here back on 2:15 maybe. So anticipate 5 minutes.
Okay.
We can be back at 2:15. I think it's time enough for us to have lunch.
So
okay?
for the presenters of the afternoon, don't forget to upload the slides on the laptop. And if you're interested, there are some slides with information on the conference running on the screens during lunch. You can have a look.